Hello and welcome to this PostgreSQL Full Course by MindMajix. In today's data-driven world, databases are at the heart of every application, from fintech apps to e-commerce platforms and enterprise systems. Among the many database systems available, PostgreSQL stands out as one of the most powerful, reliable, and widely used open-source relational databases. PostgreSQL is known for its stability, scalability, and advanced features like support for complex queries, JSON, full-text search, and more. That's why the global tech giants, startups, and even government organizations trust PostgreSQL to handle mission-critical data. In this full course, we will cover everything from the basics of PostgreSQL, database design, SQL queries, indexing, transaction, and performance tuning to advanced concepts like replication, partitioning, and working with PostgreSQL in cloud environments. According to the job market insights in India, PostgreSQL developers, database admins, and data engineers earn on average between 6 to 18 lakh rupees per annum in India, depending on their experience. With cloud platforms like AWS, Azure, and Google Cloud offering managed PostgreSQL services, demand for PostgreSQL skills is only set to rise further. And if you want to learn paid PostgreSQL course with certification, then check out our course where we will cover latest industry curriculum, hands-on projects, labs, mock interviews, and more. So let's dive in and master PostgreSQL database together.
So let's begin with the introduction part then. So it is a very small introduction to PostgreSQL database. And after the installation module, we'll directly jump to installation part. So in this module, I'm going to cover the PostgreSQL, about the PostgreSQL database and the history of the PostgreSQL and the major features of PostgreSQL. Then we will also see what are the limits are available, limits are there in PostgreSQL database, and the what are the names that have been used in the PostgreSQL world. That is a common names. So what is PostgreSQL? So PostgreSQL is basically a database which is the ORDBMS, which is the Object Relational Database System, which is a powerful open source object relational database system. It is not the proprietary database, it is the open source database, and that uses the extended and the SQL languages combined with the many features that safely stores the scale the most complicated data workload. So PostgreSQL database is used to store your data. Your value data is stored in a PostgreSQL database, which is the security, which provide the security, and which is also use the SQL languages, and it provides the scalability for your complicated data workloads. So database is nothing but where you are storing the data. You are storing the data on the database. That is PostgreSQL database. There are many databases in the market, SQL Server, Oracle. So those are the proprietary database. So here is the advantage of the PostgreSQL is the open source. You don't need to pay anyone. You don't need to buy any subscription from the anyone. You can simply download and you can use it. And it is a world and it is the world's most advanced open source database, and it is designed for the extensibility and the customization, and it is actively developed more than 20 years now, and it is ANSI ISO compliant SQL support, and it is first developed in 1986 in University of California in Berkeley. So it is PostgreSQL not only used for the relational database. PostgreSQL also support for the non-relational database like MongoDB. It will use to store the documentary data type using the JSON and the JSON data types. So PostgreSQL can accept the workload of non-relational data types, relational databases. So features of the PostgreSQL. So PostgreSQL written in the ANSI program, and it supports the Windows, Linux, Mac OS, and the major Unix platform. So you can install the PostgreSQL on Windows machine, Linux machine, Mac operating system, and the major Unix platform. And Postgres will use as it's an ACID compliant database system, and it supports the transactional logging, and it supports the save point, and it also supports for the transaction logging. That is the wall right head logging in PostgreSQL. Under the scalability, PostgreSQL uses the multi-version concurrency control for the transaction, and it is PostgreSQL also support for the table partitioning, and there is a full support for the table spaces, and the PostgreSQL also support the parallel sequential scan. Under the security, in a PostgreSQL, it uses the host-based access control to secure your database. And PostgreSQL also enables you the object level permission and the row level security. You can also configure the logging in a PostgreSQL to track down the events of your database. And PostgreSQL also allows you to configure the SSL connection to secure your database, to secure your connection. Other features like PostgreSQL supports the recovery and the high availability. So you can configure the PostgreSQL database for the replication purpose using the asynchronous and synchronous method. PostgreSQL also support for the logical replication. It supports the hot backup and the point-in-time recovery. Under the advanced feature, PostgreSQL supports the stored functions, procedures, triggers, tables, metallized view, and procedures language also supported. You can use the PL, PGSQL, Perl, Python, and other languages also. And PostgreSQL, as I said, PostgreSQL supports the JSON path expression to store the documentary data. And PostgreSQL also uses the foreign data wrappers, which will allows you to add additional functionality in your database. And additional functionality like PostGIS, and there are many other additional extension that we will see in the coming modules. That is the basically a plugins that you can add and use it in your database. PostgreSQL, there are limitation on the database, like on your database size. So, but in the database size, there is no limitation. You can have any size on database. There is no limit on the database. But there is a limit on your table size, that is 32 TB. One table may have only the 32 GB. You cannot store more than 32 GB data in a one table. The last table size is 32 TB in a PostgreSQL. And the maximum row size in a one table, that is a 1.6 TB. You can have a 1.6 TB of one row inside the table. And the maximum field size, that is one column size, that is one field size is 1 GB. You cannot store the more than 1 GB data inside the column. And the maximum row per table is unlimited. Again, there is no limit for the number of rows inside the table. But when you create a table and store the data on the table, there is a limit on, that is a 32 TB. And for each row on the table, that is 1.6 TB. And the one field, that is the one column, that value you store on the column, particular value, that cannot cross 1 GB. And the maximum row per table, that is again unlimited, there is no limit. And maximum column per table, that is the 252 1600. Again, that is depends how many columns type. And the maximum indexes per table, that is unlimited. There is no limit for creating the indexes. You can create any number of indexes on the table. So these are the basic limitation on the PostgreSQL. There are some common names that have been used in the PostgreSQL, and again, that is not mandatory to know this, but as a DBA, if you know, then it would be good for you. Like in other database world, we call it table or indices. But in a PostgreSQL, we call it relation. When we say relation, that means that table or indices. And when you say tuples, that means it is a row. Normally, other database language we call it row, but in PostgreSQL we call it tuple. The tuple means a row. Other database we normally call it a column, but in a PostgreSQL we call it attribute. And data blocks. Data blocks is like when the data is on a disk, the block is on a disk, which is called as a page in PostgreSQL. We call it page. The each page is 8 KB. So 8 KB pages. That's when the data is blocked on in a disk. We call it page. But if the same data is on a memory, then we call it buffer. So that is the difference. So when we call it page, and page is nothing but it is data you are storing on your table. Let's say if you are creating the table file is created on your hard drive. That means storage. So it will store the data on a pages. So each page is a 8 KB, and that is what when that page is on a disk, it is a page, and when that is blocks on a memory, it is called buffer. That is the difference in when you compare to other database. Next, I'll simply move to the installation part. So that is the second module of PostgreSQL. So we'll see how to install the PostgreSQL. Let's start the installation module. I'll start with the OS user and the permission. What are the user permission are required to install the PostgreSQL, and what are the installation options are available in PostgreSQL. We will see that what are the options are available. Then we will see installation of the PostgreSQL on Windows and the Linux machine. Then setting the environmental variable. How we can set the environmental variable? That is the post installation settings. First, we need a user permission to install the Postgres. Whenever you do something on the Windows or a Linux, any platform, we require the operating system user permission. Especially you install, or if you add something, or if you remove something, we need a separate additional privileges. That is comes from the admin user. In a Windows, we call it administrator. That user by default has all the privileges. That user can do anything on your system. The same way Linux, we have a root user, which is the master user for the operating system. PostgreSQL basically runs as a daemon on the Linux and the services are the Windows. That means it is a process. So whenever you install the PostgreSQL, it is runs as a daemon in a Linux and a services as a Windows. And PostgreSQL services server installation requires the super user. So for installation purpose, you need a super user or administrator user access to install the PostgreSQL, and all the process and the data file must be owned by the user in the operating system. And during the installation PostgreSQL, locked user will be created on the Linux. On the Windows, it requires a password. So on the both the machine, there will be a background PostgreSQL user is created. That is the operating system user is created in the background. And SC Linux must be permission mode on the system with the SC Linux system. This option is only required in the Linux machine. But if you are using the Windows and if you are using any antivirus on your system, you need to be very careful. Sometimes your antivirus will block the installation. Or if you have enabled the firewall, that may also cause the problem. So that's why we need to check these are the basic things of the operating system before installing your system. And again, for installing the PostgreSQL binary on the Windows or any operating system, you need a super user access. That means administrator or a root user access. So let's say user account. It is always advised to run a PostgreSQL server under a separate user account. Do not mix the PostgreSQL services with the other user. Let's say if you are using the PostgreSQL with some other machine and that machine has been used for some other purpose, then do not mix that. Use a separate user account to run the PostgreSQL. And this account should own the data directory that is managed by the server. So your Postgres server is installed on the one directory. That is what we call the data directory. So all the data are stored on that directory. So that directory must be owned by the cluster owner. The user add or add user command can be used to add a user. Optionally, if you can create the user in the Linux using the add user or the user add command. On the Windows, you can simply create new user and you can click on the use, otherwise installation will create the user. So there are 4 types of installation method that you can use to install the PostgreSQL. The first method is the wizard installation. So that is what the interactive installation method. So it supports only for the Windows and the Mac operating system. So if you are installing the PostgreSQL on Windows or a Mac operating system, then you can use the interactive installation method. But for Linux and other version, there is no interactive method is available. That means that when you say setup in the Linux, the exe file, that is not available for other. So it is only available for the Mac operating system and the Windows. And the second option is the RPM installation. This method is only used in the Linux and Unix platform, and um, there are RPM packages available. You need to download this, and this is also called as a offline installation because this does not require the internet access on your server. You can simply download it from other machine and you can transfer that RPM files to your server and you can use the RPM command to install it. We will see how to install this in Linux. And while installing the RPM installer, if any dependencies are required, if there is any dependency on the if dependencies from the operating system, sometimes the PostgreSQL requires some other dependencies packages. If it is anything required, then that you need to manually fix it. You need to fix it manually by downloading it manually. Third option is the yum installation. That is what called a package installation. So for this, we need a yum server or the internet connection on your server that will basically download from the source server, which is basically we call it global server, which is a yum server, and directly download and install it on your machine. So this requires internet on your machine, and this will fix all the dependency automatically. If it is any dependencies are there, then it will download it automatically and install it on your machine. And the fourth method, and very rarely used method, is the source code. So as I said, the PostgreSQL is open source. Then there's a source code file is also available on the server. We can download it and you can use it for installing. You can compile it. So while compiling, if you wanted to change the default setting, very rarely case with this method is used, but as a DBA, you should know this. These are the method we can use it. So we can use the source code to download. We can download the source code and install the PostgreSQL using source code. The first method is a wizard installation. So what is wizard installation? It is a Windows installation. It is a one-click installation. Just click on the exe and run it next. That will be installed on your machine. So to install the machine, to install it, first you need to download the PostgreSQL installation file from the PostgreSQL.org file or website and extract it. Simply extract it and click the right click and run as administrator because it requires the administrator privilege to run the binary. Once you run it, it will check for the dependency first. If it is any dependency required, it will try to download and install the Windows dependency. But if there is no any dependency is not required, then it will pop up the welcome screen. This is what setup welcome. Here you can simply click next to continue the installation. You don't need to change anything because it's just a welcome screen. And the next screen it will prompt you to choose the home directory. This is the home directory for your PostgreSQL installation. By default, in the Windows, it will goes inside the C program files, PostgreSQL, and your version. If you wanted to place it on some other directory, you can place it. Choose the installation directory and click next to continue the installation. And next, it will ask you to what component you need to install. Like if you wanted to install the PostgreSQL server, by default it is marked, and the PG admin, it is a graphical tool for your PostgreSQL, and the stack builder, it is an updatable tool, and the command line tool. If you wanted to install 4, just mark check mark this and click next to install the PostgreSQL server. If you don't want any option, like if you don't want to install the stack builder or a PG admin, you can uncheck and click next. So basically server will install all the server components, and the PG admin install the graphical components, stack builder install the stack builder components, and the command line install the command line. So we will see what all these tools and what are the use of these tools. Once that is chosen and the click next, it will ask you to choose the data directory. So this is very important where you keep your database. This directory stores all your database information, like your table, whatever you create table, you user, your data, whatever data you store. So everything will be stored inside this directory. By default, this directory also goes inside your home directory of PostgreSQL, which is C program files, PostgreSQL, and the version, then the data directory. So if you don't want to keep it inside your home directory, you can place it inside the any other directory. And whenever you install it on a production server, so we basically store the data directory on a separate media because of the performance and the size. We basically do not keep the data directory inside our server inbuilt hard drive. We keep it on the different media. That is why here you can change the data directory, and not only here, you can also change the data directory after the installation also. So simply choose the data directory and click next to continue and provide the database supervisor. It will ask you to enter the password for the database super user. Again, this is not for your operating system password. This is asking the password for the super user PostgreSQL for the database. Simply type the password and retype the password and click next. So next it will take you to the port number. This is the port number or where PostgreSQL run. So by default is 5432. So if you want to change the port number, you can use it, and this port number is used by your PostgreSQL server. Whenever you connect the database, so you need to provide the port number of your database, that is 5432 by default. And it will ask you to choose the locally and the language for your database. You can use the default for use the default setting. So once that is done, it will show you the summary of your selection. So what types you have selected, and you can save this for your future use, and you can simply click the next to install the PostgreSQL. It will install the PostgreSQL. Before moving to another installation method, just you can simply install the PostgreSQL on your Windows machine. To install the PostgreSQL on your Windows machine, first we need to download the PostgreSQL. To download the PostgreSQL, we need to visit PostgreSQL.org website. So this is the official website for the PostgreSQL. You can see I open the PostgreSQL website, and here is the download option. Click on download, and it will ask you to which version, so which platform you wanted to install. If you wanted to install on a Linux, click on Linux. If you wanted to Mac operating system, click on the Mac operating system. If you wanted to download for a Windows, click Windows. Here I will show you how to install. Again, so it is clearly showing download the installer in directory from the downloader installer certified by the EDP. So to download this, click here, download the installer. It will take you to the another window, and here you can download. So the latest version is available, that is the 13. You can see if you wanted to download the old version, you can also download from here. The old version is also available here. So you can also download the old version like one click installer for the Linux as well. But from the PostgreSQL version 11, they have stopped the one-click installer for the Linux environment. Only for the Windows and the Mac OS it is available. So if you wanted to download the PostgreSQL for Windows, then simply click here to download. it will download the binaries for you. You can simply install it. I already downloaded and I have PostgreSQL 13 on my machine. So this is what my PostgreSQL 13. You can simply click here to download the PostgreSQL. So if you want to download Windows, just click the Windows, it will download. You can see it will say here it is started downloading. So I already downloaded, so I'll simply cancel this. The PostgreSQL 13.1, which is the latest version of PostgreSQL. So here is my 13.1, the Windows binary I have downloaded. To install this, simply right click on this, run as an administrator. If you are already in an administrator account, you can simply run or click the run as an administrator. It will check the internet connection, it will check the compatibility issue and dependencies. If everything checks fine, it will launch the welcome screen. It will wait for 2 minutes, check the 2 minutes, and here it is, you can see this is the first screen I'll get. So this is what the welcome to PostgreSQL setup wizard. So to continue the installation, simply click next. Simply scroll down this, okay. So simply click next, and this is the installation path. You can see C program files PostgreSQL 13. So if you don't want to install the C drive, if you wanted to install it on other drive, you can simply click on here. So here it will show you, if you wanted to choose some other, you can choose some other directory. So let's say D drive. If you wanted to create D drive, you can choose the D drive. But I'll keep my default param path because it's just installing the software. I'll simply click next to continue. You can see it is asking me to choose the version, the PostgreSQL server, which is the server, which will install the server component. And this is the PG admin, which is a graphical tool for accessing your database. And the stack builder is the tool to download the updates for your server. And the command line tool, which is the command line tool to access your server. We will see what is this PG admin and the command line, how we can access that tool. And then if you wanted to continue, simply click next. And here it is asking the directory to store the database. This is the where PostgreSQL store your entire database. All the directory, all the configuration file, everything will be stored inside this data directory. So by default, this data directory goes inside your home directory, but optionally, if you wanted to place it on a different directory, you can simply click here and change the data directory. For this, I use the default one and I'll click next. Next, it is check. You can see this is what the installation. It may ask you to choose the port number because it is already in my server. It is already configured. This is why it's taken 5432. And if you're installing first time, then it may ask you to choose the local type. You can use the default one and simply click next to install. You can see setup is ready to begin the installation on server. You can simply click the installation. It will take 1 to 3 minutes to install the PostgreSQL on your Windows platform. So this is how you can install the PostgreSQL on. Once it is installed, it will create the database in the background. And you can access the database using the pgadmin or Psql prompt, which is the Psql is the command line and the pgadmin is the graphical tool to access your database. It will take on 2-3 minutes to complete. So that time, I'll simply start the next method. So that is the yum installation. YAML installation, this is only possible on your Linux machine. You cannot do it on a Windows because it is a Linux feature. So basically, we use the database production database on a maximum a Linux machine. Very rare case we use the Windows for production, because in a Linux it gives them more performance. That is the way all the organizations choose the Linux platform for the database, and it is the security also. There is no virus issue, there is no other problem, so it is more secure from operate Windows. That is why you use the Linux. To use the Linux, the easiest way to install the PostgreSQL is the yum installation or a package installation. To install the package installation, you can simply visit the same website, that is PostgreSQL.org. This is the website you can visit, and the same thing you can click on download here. It will take you to the download page. Here it will ask you to choose the platform, that where you wanted to, which platform you wanted to install. Here I'll select Linux. You can see when I click the Linux here, down and more rows come. So these are the Linux versions: dbn, Red Hat, CentOS, SUSE, Ubuntu, and the other Linux. I'll use the Red Hat. So it is Red Hat. If you click Red Hat, it will take you to another screen, and you can see here, if you scroll down, it's giving the yum repository for Red Hat, CentOS, Scientific Linux, Oracle Linux, and Fedora. For this many Linux version, you can use the same page. Again, it will saying that use the PostgreSQL result to follow these steps. So first, it is saying the select version. So which version you wanted to install? PostgreSQL 13, 12, 11, 10, 9.6, 9.5 is available. I'll use the latest one, that is 13. I'll select 13 version, and the select platform, that will I'll select my platform is the latest, that is also Enterprise, Red Hat Enterprise version 8. So it is a Red Hat Enterprise, CentOS, Scientific, or Oracle. If for any of this operating system, you can choose this, and for Fedora, it is down. So it is again 876. So my is 8. So I'll select 8. And this is the architecture. My architecture is the 86_64. And it is generated the some script. You need to simply execute script on your machine. So if you have internet connection, then this command will download and install the PostgreSQL on your server. So before executing this, I'll simply connect to my cloud machine. So I've created already one cloud machine. So it is the installation cloud. So I'll click on this, and I'll copy the public IP of this machine. So this is my address. I simply copied, and I'll open the putty, which is the SSH tool to connect the server. And I already downloaded the I simply make this. I already downloaded the key for my server. So here I'll use my key for connecting the server. So it is in the desktop installation, demo installation PK, that is what key. So here I am connecting my server. It is asking me to iPhone user, that is the username I'm providing to connect. You can see here, and I'll switch to root user to sudo su iPhone. So I'm the root user. Now I can use the install the PostgreSQL. So I'm in the root user. Root use the super user in Linux machine. So if you wanted to check the version of your machine, so that is a /process red hat /etc red hat release. So you can see I'm using Red Hat Enterprise Linux, that's the 8.3 version. So here you can see same thing I have chosen while downloading. So I'm choosing that. This is the Postgres version, and I'm using Red Hat Enterprise. The version is 8, and architecture is the 64. So now I need to execute this command. So I'll use one by one command. You can simply copy all the command and I'll use first this is. So this will download the RPM file and install it. The RPM file contains the PostgreSQL binary information. So let's paste it here. Simply I'll paste and enter it. So it will connect to server and it will download the file and it will install. You can see it is installed. So next, this command to disable the built-in PostgreSQL molded from your server, because Linux server comes with a PostgreSQL that is the older version. So that is why this command to disable the PostgreSQL older binaries. Once it is done, just install the PostgreSQL, that is dnf install PostgreSQL 13-server. So simply install it. It will download and install the PostgreSQL. So you can see the PostgreSQL server, lib, and so this many packages will downloaded. You can see it is preparing, downloading, and installed. The installation is complete. This is what PostgreSQL binary is installed. And in the Linux, the PostgreSQL will be installed inside the /user PGSQL 13 bin. This is the binary directory for your PostgreSQL in the Linux machine. So you can see all the binaries are kept inside the bin directory. And the by default the data directory goes inside the ls var lib pgsql and the data. Sorry, pgsql 13 and data. So this is the data directory which is empty. Because I have simply installed the PostgreSQL, I have not created any server or a cluster. To create the server, here is the command, that is PostgreSQL 13 setup initdb. It will launch the default cluster on your data directory, which is default data directory. But if you want to change it, you can change the data directory as well. That we'll see in the cluster module how to generate that. But as of now, I'll simply create the default cluster. Now you can see, to start the cluster, you need to run pgctl start command. So enable to start up in a server startup, but I skip that and I'll simply use the start command to start my cluster. So my PostgreSQL cluster is created. As I told you, whenever you install the PostgreSQL on a Linux, in the background, the Postgres user is created. That is what you can switch to Postgres user. Now you can see ps-elf and pipe grep PostgreSQL, which is basically list you the PostgreSQL processes. This is what the Postgres process is running on my Linux machine. Here it is not asked any port number, anything, because it is used the default. The port number is 5432. That will show you how to check the port number and where that file is kept. So this is, you can see, this is my home directory, that is the user pgsql 13 bin, and this is my data directory var lib psql 13 data. All the files and folders are kept inside this. You can see ls-l, and you can check the data directory. See, these are the data directory information. So we will see all of the, we'll go through all of these files and folders inside the data directory in the architecture module. So, but as of now, this is created. So we have seen that while installing the Windows, there are PG admin tools are installed and the command line prod tool are installed. The command line tool is the PSQL to connect your database. So using this, you need to provide the port number by -p, which is 5432, and capital U to specify the username, that is Postgres is the default user. and -d to specify your database name, that is by default Postgres. Simply click, it will connect to your server. You can see I'm logged into Postgres database. So default database will be three database will be created inside your cluster. The Postgres, template 0, template 1. These are the default database will be created whenever you install the PostgreSQL. This is what PostgreSQL database the default installation on Linux using the yum installation. So here you can see my Linux Windows installation is completed now. You can see this is in the last stage. And I'll simply unmark this and finish. The installation is complete. To access the Windows, you need to go click on your start button. So in the start all up and search for the PostgreSQL 13, or you can also open a command prompt and you can run it. So there is a SQL cell, PSQL prompt. So it will show you like this. It will comes like this. It is saying the server localhost. It is running on my local machine. Yes, it is localhost. I'll enter, or you can type the user. And it is saying that which database? Postgres. The by default Postgres. I'll use the default one. And port we have chosen default, that is a 5432. I'll enter again. And the username, it is saying that what is the username, and it will ask you the password. So my password is a Postgres. So I'll type the use password for this and I'll enter. It will connect my cluster. This is what I get. So you can see here also \L to list the database. I have a 4 database. This is one I previously created, and you can see the default 3 database. There is a PostgreSQL template 1 and the template 0. So this is the PSQL prompt to connect your database, which is the command line tool. On the same way, you have a PG admin, which is the graphical tool. We will see in the coming module how to use the PG admin and PSQL command line tool to access the database in detail. Another method we use to install the PostgreSQL is the RPM installation, which is also called as a offline installation method. So to download that RPM installation, same thing again we need to do. That is go to the PostgreSQL.org website and click on the download option. So here you can see this is the first method, and click on the download. And here is the option which will ask you to download this thing, which is you need to go inside yum package. So there is the RPM package. You can use it yum.postgresql.org website. So not the postgresql.org, yum.postgresql.org. Otherwise you need to search for the yum. So you can see here is the RPM chart. Click on the RPM chart and scroll down it. The PostgreSQL 13 is the latest version. Here is the operating system. So which operating system? Again, RPM is also only supported in the Linux. So if you are looking for the RHL 8, click on the RHL 8. So you can see these are the list of the RPMs. You need to download only the 4 RPMs, which is PostgreSQL 13 server, library, and the devil. So only 4 binaries required for installing the PostgreSQL. So others are we'll see what is the PG pool. There are many. So which is all the dependency programs which you can download and install it. You can download and install it if you wanted to use it. So otherwise you can simply download only the PostgreSQL download PGDG, country model, devil model, and optionally lib module, and the server module. Only the 4 packages you required for installing the PostgreSQL. You can download it manually by clicking on this file. So here is the PostgreSQL 13.1. So I'll simply click on this. That RPM is downloaded here. Once it is downloaded, all the RPMs, you can simply copy this to your server and you can install it. This is the another method you can use it for installing. So I'll not show you this because this is simply you can run the RPM installation. This is here in my script. To install it, you can use the RPM. So same like you can also use the yum local install to run the RPM installation your server. Another method is the source code installation. This is very rarely installed, very rarely that organizations will choose this because we already have a compiled RPM and the packages. But as a TPA, you should know the another option to install the PostgreSQL. So I'm not performing this installation method. I'm not showing any demo for this, but I have a installation steps here that you can follow if you wanted to check it for the testing purpose. To install the using the source code, first you need to download the source code from your PostgreSQL website, that is ftp.postgresql.org website. So this is called ftp.postgresql.org website, and click on the pub directory and check the source code. Here is the source. Click on the source and here you can see the versions of the database. So if you wanted to download the PostgreSQL 13, so here is the PostgreSQL 13.1. Click on the 13.1 and here is the zip file. You can simply click on this file to generate the tar.bzip. Click on here, it will generate and copy this file to your server and untar it. So I'll simply cancel this. I don't want to because I already downloaded, I have this file. So I'll cancel this. So once that is downloaded, copy to your server wherever you want to install it. And to compile this, you need to download some dependency program files, program packages. That is what GCC, libc, table, and the readline table. This information is required for installing the PostgreSQL on your Linux machine using the source code. You can use the yum installation, RPM installation, any method to install the dependency. This is again the operating system dependency. So once that is installed, then copy the downloaded file and extract that file using the untar command and go inside the directory and run the configure command with the help option. It will list to the all the available option and use create the directory to which directory you wanted to install and use the configure method -f prefix with your created directory so that PostgreSQL install and extract all the files on the directory. Once that is done, use the make and make install to install the PostgreSQL, which is the method to compile the PostgreSQL using the source code. So once it is done, then you need to create the directory and the username manually, because here you need to create it everything manually. Using any other Windows or a binary installation or a RPM installation or a yum installation, everything will be automated. But herein, you need to create all the steps manually. So create a user first and set the password for the user, then create the directory for storing the database, then change the database owner and run the initdb command to initialize the cluster. This is what initdb will initialize the cluster on this your directory. So this is the step you need to follow to install the PostgreSQL. So once the installation is done, using any method, you can set the environmental variable. So this is to ease of connecting. So instead of providing every time your host name, port number, database name, username, you can set this in a a variable. In a Windows, we call it on the system like on the machine. We basically right click on when environmental variable path is available. On the advanced setting, we can see there is the environmental variable. Sorry, performance. Yeah, here is an environmental variable, and here you need to add the path. So you can set the path here. So sorry, here is a path. You can add your binary information, binary path of the PostgreSQL, and you can add the same thing which I showed you here. The PG host for a host name, PG port for the equal to port number, PG database equal to the database name, and the user equal to username, and optionally you can set the password. So that whenever you log in the database, you can no need to pass this information. All this username, port, database, you don't need to type. You can simply execute the PSQL, and that will read this all the information from your binary this environmental variable and connect to your database. That is what post installation steps. And this is not mandatory. This is optionally again. Let's just start the architecture part then. So in this module, I'm going to cover the architecture summary and the memory architecture and the background utility architecture, and we will see connection, request and response operation, and we will also see disk read and write buffering, and we will also talk about the what is commit and checkpoint in PostgreSQL and what happens when you write a commit and checkpoint, and we will also see the statement processing overview, and we will also discuss about the physical database architecture and the data dictionary layout, data directory layout. PostgreSQL architecture summary. The PostgreSQL server uses the processes. It does not use a thread. The Postgres is a process based, not a threaded. Postgres does not use a thread at all. The postmaster process, also called as the supervisor process. In a Postgres, whenever you start the database, the topmost process is started. That is the postmaster process. This is also called as the supervisor process because the postmaster is responsible for starting the all other processes like utility processes. These are the utility processes basically carry its own background works, and each user also has its own backend process that is called the Postgres process. And PostgreSQL work as a listener. It is listen for the user connection, that is a new connection. There is no separate listener available in PostgreSQL. The postmaster itself acts as a listener. So when you connect the database, the postmaster is going to receive that connection and accept the request from the user, and I complete the authentication and authorization for the user. So this is all the background overview. So whenever you start the database, the postmaster is started, and postmaster is responsible for starting the all other child processes like the means utility processes. So here you can see the architecture of a diagram. This diagram describes all the internals of the running PostgreSQL instance. The top post, you can see the postmaster. There is the postmaster process. As I said, whenever you start the PostgreSQL, the topmost process is started. So that is what here you can see on the screen. That is the postmaster process. And in the next, you can see shared buffer. So that is the memory area is allocated whenever that you run a whenever you start the Postgres server. The topmost is the postmaster process, and postmaster once started, it will allocate the memory area which is shared memory area. Inside the shared memory, postmaster also allocate two more memory area which is shared buffer area and the wall buffer area. Then we will start the process array. The shared memory area is the very important which where all the transaction will happen in the shared buffer area. And the wall buffer to write all the transaction inside the transaction. All the transaction will happen inside the wall buffer. And processor like the background processor like a DG writer, checkpointer, stat collector, wall writer, auto vacuum, logger, archiver, and the logical duplication. These are the utility processor also runs in the background. And in the storage side, you can see data files, error log files, wall segment, and the archive. These are the files you can see inside the on your storage. So Now you started the database and the postmaster service is started. That is what you can see in the top, the postmaster's process. The postmaster's process is started and postmaster is allocated the memory area into the shared underscore memory. And inside the shared memory area, there is a two more memory areas, which is the shared underscore buffer. So shared underscore buffer is the very important memory area because whatever you do on the database, insert updates, select, everything will execute inside the shared underscore buffer. And this is why this is very important. Based on the parameter value, it will allocate a size for the shared underscore buffer. And the shared wall underscore buffer. This is the area where all the transaction logs are returned. So user transaction details like the select update insert that will be returned inside the shared buffer and the wall buffer. So whenever the user writes a commit statement, the wall buffer is immediately synced to wall segment. That is what the wall directory. So these are the important memory area in PostgreSQL also allocated whenever you start the database, and postmaster is the responsible for to start this process. Once this memory allocation is complete and the shared buffer and the wall buffer is allocated, then postmaster will start the background utility programs, which is DG writer, stat collector, auto vacuum, archiver. These are the utility processes which runs in the background. And all of this utility process is supervised by the postmaster process. On the storage side, you can see data file. So this is where all your PostgreSQL data are captured. This is the data files. Whenever you create a table, you create a database, that files are stored inside your data directory. That is what data files. And error logs. So error logs also kept inside your data directory. So it will collect all the database events and store it inside it. These are the default directories inside your data directory. And wall underscore segment is the wall segment area. That's what I said. Whatever the records you write on the wall buffer, that will be synced after after the commit. So that is the phase it will sync. That's the wall underscore segment area. And if we enable the archiving, then you will also see the archiving directly on your storage. So let's see one by one about this processes. The utility processes, the background writer. So first background is the background writer, and this is responsible for writing the dirty buffers from the shared buffer to wall buffer. So what is dirty buffer from the shared buffer then? So shared buffer is a memory area on the Postgres server. It is a memory allocated for your transaction or your activities on the database. So whenever you connect to database and if you create table or if you write a insert into the same commands on the database, that will be executed on the shared underscore buffer. And let's say that you are inserted one record inside your table, and record is simply created on the shared underscore buffer and the wall underscore buffer. Both the place is the memory area. These two areas also used for the transaction. Whenever you insert the record, that record is simply created on the memory area. Now you write the commit. And on the shared buffer, this memory is simply marked as a committed. Suppose what it does, it simply marks this row as a committed. The BG writer is the background utility process which runs in the background and sync that, means copy that data from the memory to your disk, that means your storage, your data file. It will copy that, it will sync that data, directive buffer, that is what we call a directive buffer on the shared storage. That space where data is synced from your wall file to synced from the shared buffer to your disk. This is job of the DG writer. It is continuously run in the background and it will copy directive buffer from the shared buffer to your disk. And another is the checkpoint. So checkpoint will automatically perform the checkpoint based on the computer parameter. So checkpoint happens in every 5 minutes, and it will clear all the memory from your shared buffer, and it will, checkpoint will also happen on your wall wall buffer as well. So checkpoint happens every 5 minutes and it will clear all the memory and sync to your disk. And we have another background utility processes that is the wall underscore writer. So it is similar like a beach writer, but the job is completely different. So beach writers used to write the data buffer from your shared buffer, and the wall writer is used to write the data from the wall buffer to wall segment. That means this. So whenever user writes the transaction other than that transaction is created inside the shared buffer and the wall buffer. Why these two areas? I'll tell you why these two areas. But whenever you write that, let's say if you are inserting one row, that row is created inside the shared buffer and the wall buffer. So whenever you write the commit statement on the shared memory, it is simply committed as it is simply marked as a committed statement. But in the wall buffer, what happens? It immediately after the very next commit, after the commit, it will very next it will simply sync that transaction to your disk. That is what wall segment. This is what provides you the data durability in a PostgreSQL. Let's think that you have a server and you have inserted the record, and that record is created on a memory where in a shared buffer and then a wall buffer. Think that there is no wall buffer area, only the shared buffer area is available. And you have inserted data, that data is lying on the memory now, and you written a commit. You committed the transaction, and that statement is marked as a committed now. But data is still on the memory, it is not synced to your data because the BG writer is not performed. So in this time, if server is goes down, you will lose this data because data is simply marked on the memory. It's committed on the memory, not written in a disk. So that is the use of that is why you use the wall buffer area, because wall buffer basically that is the use of the wall buffer, because whenever you write a transaction on a wall, it will whenever you write the statement is captured with the shared buffer and the wall buffer. But whenever user write a commit statement, that statement from the wall buffer after the next commit, it will sync the data to wall segment. But in the shared buffer, still the data is marked as committed, that not at sync to your data file. Now if your server goes down, the shared buffer memory will be go, because that you cannot recover. That will go because that is a memory. Whenever the server goes down, the memory will be cleared. If that server comes up, so the memory will be refreshed and there is no committed data available on your memory. In a wall buffer, the data is committed and data is synced to your wall file. That is the wall segment. Postgres will read that data from your wall file and sync that data to disk. That is what it provides the data durability. If all the recorded committed transaction is available in wall file. That is why we use the wall transaction log in Postgres. That is the wall stand for write head logging. So this is the job of the wall writer to sync the data after the commit. Next we have a background utility function called auto vacuum and launcher and the worker. So this is the launcher and the worker process which will launch on the specified launch on time or a threshold that defined in a parameter. But this the job is to basically working in the table. That means removing the dead rows from your table. That we will see what is actually a vacuum and launcher workers in PostgreSQL on maintenance module. There are a separate module for that. We'll understand what is that. But as of now, there is a background processing which starts in the background. That is the auto vacuum workers. And there is another utility function will run in the background, that is the logging. So logging, the job is to collect the error information of your database. It will collect the error information and store it inside your wall directory. In Windows, it will store inside the event log, and by default, it is the standard method to log. That means it will create inside your log directory, inside your data directory. And if you wanted to use that log on your Windows log directory, then you can use this log method. And another method is the archiver. So another process, the archiver. So archive is the optional. If you wanted to copy each your historical wall file, that's the write and transaction log file, then you need to enable the archive. By default, this parameter is not enabled and this utility function will not run in the background by default. You need to enable it if that is also if it is required. So if you are enable the archiver, then it will archiver process will run in the background whenever that your WAL file that is by default 16 MB, that 16 MB file is full and ready to create another file, the previous file will be copied to your archive destination. That's what I said. It is used to keep the historical log file on your server. So we will see what is archiver and how to use it in a coming session. But right now, the background, there is a process in the background, which is archive. And the stat collector code. Stat collector job is to collecting the statistic of your database. It will collect the statistic and code inside the catalog. So it will collect the statistic information and it will, runs in the background. So it collects the relational information and the block information of the database. So these are the iterative functions runs in the background to basically carry it forward. So this is what their job. So to update the configurator job is to copy the data file from the shared buffer to this wall writer to write the wall buffer to the wall segment, and the set pointer is to run the set pointer on the shared buffer and the wall buffer. Then auto vacuum launcher and the worker to launch the vacuum workers on your database, and the logging to collect the error information at your database and store it inside the log directory, and the archiver is to copy your filled wall file from the wall segment to archive directory to store the historical log file. Then tag collector is to use it to collect the statistic of your database. So these are the background utility that runs in the background whenever you start your database. And if this process is died, then postmaster is responsible to restart this process. So the postmaster is the topmost process. Whenever you start the database, the topmost process is started. And also I said postmaster is the restart process. There is no separate listener. The postmaster is going to listen to the user connection. That means if you are connecting to your server, that means that connection is received by the postmaster host. Here in the diagram, you can see the user client is connected to the server and the postmaster is receiving this connection on the server side. And postmaster is responsible for receiving the client request. And once the client request is received by the postmaster span new process for each connection request. So once the process is received by the postmaster, then it will span a new process for each connection called Postgres, and it will check the IP address and the user and the password of that connection user. To check the IP user and the password for that user, then it will verify the permission. Whether the user has the permission for the to connect the database or to access the tables on your database. And once it is all done, it will communicate. It will create the process that is called Postgres process for each user. If 10 user is connecting, then you will see the 10 Postgres process on your server. So each process as each user connected and its own Postgres process on the server. And once that process is created and the user is authorized and authentication is and authorization is done, the process is created, then the Postgres process is responsible for receiving the user connection, user query. When the process is allocated by the postmaster, it will also assign some memory for that process. That is what underscore meant. So some memory is allocated for that process, and from there onwards, the Postgres process is responsible for receiving the user query. So once you connect it to database and if you write a select star from on the table, or if you write any SQL statement, then the Postgres process is responsible for receiving that statement and executing on the statement on the database and send the result of the query back to the client. that is all done by the Postgres course. So Postmaster job will end once the new Postgres process is created. So thereafter the Postgres process is responsible for receiving and sending the query result back to the client. And all this will be done on the shared area. So once the Postmaster, that is what the user connection and request. So when the user send the request to connect the database, Postmaster will receive the connection and it will check for the authorization and authorization. Once that is done, it will sign a new post. This post is for the connection, and once that is created, then that process is responsible for receiving the SQL statement from the user, and this is responsible for receiving the user command and sending the query result back to the client. After that, we have a disk read and write buffering. So this read buffering, whenever you read the data from your server, let's say that you have a table called employee and you wanted to read the data from the employee table, you write the correct tab from EM. Basically, PostgreSQL uses the server buffer cache and the operating system cache. So if you all other database like the Postgres also use the two-phase reading, so it will use the server PostgreSQL server buffer and the operating system. Whenever you read the data, basically you read the data from the memory, but if the data is available in the memory, then data will be immediately fetched from the memory. But if data is not available in the memory, if data is stored on a disk, and if you are using if you are reading the data for the first time, then data is read from your disk because data is stored on the disk and that data is sent from the disk. So whenever you read the data, there will be one IO on your storage because it's read from the disk. That means the hard drive. So whenever you read for the first time, there will be one IO on your hard drive. And but if other user comes and read the same data after that, then for next user, the second user, third user, if they are also looking for the same data, then there is no IO on the storage for the next second and third user. Because now that data is available on the memory, once the first user is reads the data and that data is fetched to your memory and next user, the second or third user comes and read the same data, they can simply read the data from the memory because data is already there in the memory and it will read from the memory. That is why for second and third user there is no IO on the storage. This is how this read happens in the Postgres. You can see in the diagram. So there is a read. The first read is written read from the disk, and the second and third user they are reading from the shared buffer. And the same way we have a disk write buffer. So as I told, whenever you write the transaction, if you insert the row on your database, or if you insert in the rows on your table, then that row is simply inserted into the memory. That is called shared underscore buffer area, which is written into the shared underscore buffer. If you commit after the transaction is simply marked as a committed on the memory. But whenever a BG writer or a checkpoint happens on the database, that data is synced to your memory to disk. That means your hard drive. So in that time, there will be one IO on your server. There will be one IO on your disk because to write the data to your disk. So whenever checkpoints happen or whenever BG writer comes, there will be IO on your server. Based on the type of pages available in storage, it will write the data onto your disk. So it will also clean the space to make a new room for your new blocks. At each checkpoint, it will clean the memory and sync all the data from your memory to disk. This is what the disk write buffer. So there will be IO whenever the checkpoint or the generator and background writer. The same thing whenever the background, that is what I said, whenever the checkpoint or background writer will happen in the background, there is a disk IO on your storage. There is a IO. That will be one write on your server. So based on the data availability, it will write the data to your disk, and not only it write the disk, it will also clear the used memory from your shared underscore buffer. This will help to other users to write the data on a server. Then write head node. So that is what wall. After that, whenever the user writes the data goes through two phases. That is the shared buffer and the wall buffer. So whenever user writes the commit and that wall buffer, the transaction is simply marked as a committed, and where in the wall buffer it is immediately synchronized to your wall segment, which is the PG underscore wall directory inside the data direct. This is basically ensure that data durably in the Postgres. So wall writer job is to wall login is to secure your data. If it's committed data, if the data is committed, that data is immediately synced to your disk, and whatever the page is available on your shared buffer, that will be synced whenever the checkpoint or BG writer comes. In the shared wall buffer, the transaction is immediately copied to your wall log file whenever the user writes a commit state, plus the wall buffer theoretically on commit or whenever the buffer are full. Wall underscore archive. As I said, this is an optional feature. If you need it, you can enable this. This is job is why it is required. So here is the wall. The each wall file is a 16 MB. The each wall is a 16 MB, that is the transaction log file. Inside the PC underscore log file, there is a multiple files stated. So the each file is 16 MB. So all the transaction that you do on the wall buffer, after the very next commit, that transaction is copied to your wall PC underscore wall direct, and this transaction size is the 16 MB. Whenever that file is full and ready to switch to another file, whenever the file is full and ready to switch another file, so their archive command will come and copy that previously pulled wall file from the wall segment to archive destination. Why this is required? Because based on the parameter of the size of your wall segment, the PostgreSQL delete that old file. Let's say by default it's a 1 GB. And whenever the size is reached 1 GB, Postgres will start using the old file, or it will start patch the old file. But if you wanted to keep that old transaction file, you will need to enable the archiving on your database. It will simply copy your filled wall file from the wall segment to your archive destination. This is what wall segment, copying the wall segment to archiving. You can simply copy the filled transaction file from PC wall directory to your archive directory. That's it. This is the job of wall archiving process to keep the story of the wall transaction. And these transaction files are used for restoring the database in a point in time recovery. And I already told you what is commit and checkpoint. So before the commit, what happens? So if you do the transaction, that transaction is simply marked, simply returned in the memory, wherein shared buffer and the wall buffer in the both the place, the transaction is simply returned. Simply the transaction is simply lying on the memory. Whenever you write the commit, after the commit, the wall buffers are returned to disk and the shared buffers are marked as committed. There is a difference where wall buffer are immediately synced to your disk, and the shared buffer, it is still on the memory, but transaction is committed, marked as a transaction committed. Whenever the PG writer or a check pointer will come, it will check the committed transaction, that is what the battery buffer, and sync that transaction to your data directory. So after the checkpoint, the modified data pages are returned from the shared buffer to data file. This is ensure that all the data buffers are returned to your disk. Whenever the checkpoint happens, it ensure that all the data buffers from the shared buffer to is returned to disk. That is what in data direct. This is what checkpointer and commit and checkpoint in Postgres. And we should also know the statement processing. What happens when you write the sequence commands on your database? So whatever the command you execute on the database, that has to go through the SQL engine. Under the SQL engine, it has to go through these three stages, which is the parsing and optimizer and the executor. It has to go through these three stages. So let's say if you are executing the select statement, that statement is sent to the SQL engine, and the SQL engine that query has to go through this stage. The first stage is the parsing. When the query is reached the parsing, it will check the syntax of your query. Is there any problem with your syntax? If there is syntax problem found, then it will throw an error, that is syntax error. If there is no error, if your query is good, then it will call the traffic call utility and to identify the query type, what type of query, whether it is a DML query, DDL query. So DML queries are collect, insert, update, delete. These are the DML queries. And DDL statements are like a data definition statement which will create, alter, drop. It will identify the what query is there, whether it is a DML or a DDL. If it is a DDL query, data definitional query, then those queries are not required the optimization. If it is a delete, then delete does not require the optimization. Sorry, not delete. If it is a drop or a create, and this command does not require the optimization, that can be directly executed inside the executor because they are the DDL statement. And if it is a DML, the collect, insert, update, then this query requires the optimization. It will identify the query. If it is DML, then it will break the query in a token. That means it will break that query in a smaller piece like a keyword and send it to your optimizer. In the optimizer, what happens? It will generate the plan for your query. How it will generate? Based on the statistics available on your catalog table. So based on the catalog table, it will generate the plan for your query and it will choose the best plan for your query and send that query to your executor with the plan. On an executor, it will simply execute the query. This is what happens whenever you write the query on database. It will check for the syntaxes. It will check whether the query is what type of the query, and if it is a DML, it will send to the optimizer, and the optimizer will generate the plan for the query based on the statistics available on your catalog table. Then it will send to the executor to where it will execute the query and query. This is what happens in PostgreSQL whenever we write the statement. So let's then take our physical architecture. A cluster is a collection of the database managed by the one server instance. So whenever we install the database, then the one default cluster is created, that is the cluster. The cluster is a collection of database managed by the one server, and each cluster has a separate data directory, unique port number, and a set of processes. And a cluster can contain a multiple database. Your one cluster can connect a multiple database. There is no limit for creating a database in the cluster. You can create a number of databases in the cluster. And the data directory. We have installed on the Unix and we have installed on the Windows. We are seeing that in the Windows, the default binary will be created inside that program file and PostgreSQL. And the Linux, it will be created on the user is equal to 12 and the bin. And we have also the bin is used for programming. So all the programs are kept inside the bin directory. And the data directory is to store your database files and the configuration files and the folder. And the document the directory which contains the document information and the library list directory and the library file. So these are the folders you can see on your data directory. Inside the data directory, you may see many folders and the files. Let's start with the base. The base is the default table space for your database. Whatever database or the table you create on your cluster, that will be stored in the database. And the global. Global is another table space, but it is used only by the cluster one. We cannot store user-created objects inside the global directory because it is mainly used or mainly reserved for the system PostgreSQL system internal use. And pg underscore wall. This is the wall segment area I am talking about. Whenever you write the transaction, the wall statement, whenever you write the commit statement, the transaction is immediately synced to wall segment. That means the directory is pg underscore wall. This is the statement area of PostgreSQL. And a pg underscore dbms, which is the table space directory which contains the user created table space information. And the log directory, this is the error log. All the database errors are kept inside the log directory. And there are other status directories like pg logical, pg multi-expect, pg notify, pg reference log, pg serial. These are the status directory which stores all the status of the database like replication status, logical status, with the loss status, notify status, and the multi-transaction log status. Everything will be stored inside this direct. These are used by the Postgres internal and do not edit any file inside that status direct or any one of its directory. Do not edit it manually. And in a PostgreSQL, there are many configuration files, that is the PostgreSQL.autoconf, PostgreSQL.conf, PGSQL and a PGIJconf. These are the configuration files which contains the parameter of Postgres. The main configuration file is the PostgreSQL.conf and PGSQL.conf file. All the parameters are kept inside the PostgreSQL.conf. And other files like there is a postmaster script file which is created whenever you start the data, which contains all your permissions like information like the log data directory, port number, and the start date of your cluster. So that file will be created whenever you start the database, and that will be deleted whenever you stop the database. So this is the data directory layout in PostgreSQL. So in physical data architecture, so as I said that all the database files are stored inside the data directory. Then if you create a table, if you create an index, that is a file on your directory. So each file and indexes, each table and our index is a file on your table. If you are creating the table, then in the storage it will create the one file. If you create an index, then it will create a one file on another file on your storage. And if you create a table space, the table space is nothing but a directory. You are telling the PostgreSQL to store all the object on this directory. That is what the table space. And each database that you use, that table space gets a subdirectory. So if you create a database inside the table space, then your table space directory gets another subdirectory. And each relation using the table space or a database combination gets one or more files in 1 GB chunk. Because PostgreSQL uses the PostgreSQL create a 1 GB chunk of file for your table. If a table is a 10 GB, then Postgres will create the 10 files for your table. It will not use more than 1 GB. It will use a 1 GB of file storage. And additional files used to hold the auxiliary information like a free space map and visibility map. These two files are created along with your table file. So each file name is a number. So if you see if you create a EMP table on your storage, if you create a EMP table on your database, then the table is created with the OID on storage. That is what object identification number. It is a number in storage. You can use the database command to identify the OID of your table and the databases, because all the object you create on the database that will be stored on the storage using the OID. This is named after the OID of your database. So that is what PostgreSQL architecture. So let me show you this very quick demo about this. Let me connect to my instance. Okay, so this is my cluster. I connected to my Postgres instance. Let me check that Postgres is running or not. I think it's not running. To run that server, so let me start the PostgreSQL server. It is running. So now, if you want to check whether Postgres is running or not, you can check the status. But if you want to see the postmaster process, I will show you the ps-elf and pipe grep Postgres. This is the operating system command I'm executing. So this is what PostgreSQL process is running on your server, my server. So as I said, the topmost process is the postmaster. So here is the postmaster process. This is what you can check. This is the postmaster, and this is the process is supervising all my child processes. These are the child processes. You can see utility processes, the logger, checkpointer, background writer, wall writer, auto vacuum, launcher, stat collector, logical replication. These are started whenever my postmaster is started. The postmaster is responsible for starting these processes. And you can see here the PID number of my postmaster is a 1516, and same thing is supervising here my child processes. So this is why you can identify your postmaster PID and the child processes, because this process is supervising these processes. And if any this process is hanged up or dies, then this postmaster will automatically restart that processes. The postmaster is responsible for starting these processes and restarting them whenever it requires. So the postmaster is started and it start the allocate the memory areas and it will start the background utilities. And these background utilities carry its own one. So let's go inside our installation path in the PostgreSQL. In a RHEL Linux, in a Linux environment, PostgreSQL will be installed inside the user directory and the PGSQL 13. So this is the home directory of my PostgreSQL in Linux. You can see here is the bin doc share lib share. This is the directory are created when we install the PostgreSQL, and the bin is used to are kept inside the executable files. So this is what PSQL postmaster, all the executed files, and the docs it is used for the documents are kept, and the lib is the library files, and the share is for the extension. So this is what the you know binary files or the home directory looks like. Now, if I go inside the data directory, the PostgreSQL by default creates a data directory inside var lib pgsql and your version, that is 13, and the data directory. So this is my default data directory. And data directory can be created anywhere in the server. That option is available. You can store it anywhere. So you can place your database in any disk, any storage. That we'll see in the clustering part. But by default, Postgres create the data directory inside your this path. So if I run here ls-l, you can see list of the folders and the files. As I said, base is a default table space, and the global, it is the default table space for the cluster wide, and that is a log which stores the log files. And the PG commit, PG dynasty, PG logical, PG multi-exit, PG notify, rep slot, serial, snapshot, and substrat. These are all the statistics table. These are all used to record the database statistic information. So it is recommended, it is suggested that do not, it is always recommended, do not edit anything inside this directory. And there is a pg underscore tpls, which is the table space directory. If you create a user create a table space, then this table contains the symbolic link of your table space. And if we have another important directory, that is a pg underscore wall, which is the wall segment area. All the transaction logs are kept inside this directory. And the pg exit is, again, it is a status directory, so which will store the transaction information, the status information. Then PostgreSQL.autoconf, which is the empty file by default, which will be overwritten whenever you modify the parameter. We will see that for parameter configuration part. Then PostgreSQL.conf is the one parameter file which contains more than 350 parameters. So if you wanted to change any parameter, you need to go and visit this file and you need to change the parameter value. And the postmaster OPTs and pgmaster PID, which will be created whenever you start the database. And this file set contains your running PostgreSQL instance, like a port number, data directory, and the time that I started. So all the information, you can simply see cat and the postmaster PID, which will display the information of that. Your data directory, your socket directory, your port number, local address. So all the information are stored in postmaster.pid. And if you go inside the base directory, as I said, all the tables and the databases are folders in Postgres, the files in the PostgreSQL. So before that, I'll switch to Postgres user. So I wanted to show you this Postgres, and I'll go to inside my data directory, and I'll go inside that base directory. So if I run here ls-l, you can see my base directory contains 4 subdirectories. The base is the table space, which is the pg table space directory, and inside there is a 4 directory. This is what my database is. The 4 database on my server. This is the database created on my server. As I said, database is a directory on your storage, the subdirectory inside the table space directory. This is what directory. If you wanted to confirm which database, which is my database, you can connect the database and run the select OID. This is why it is always used. Postgres always use the number to store the object on the storage. The number is the OID, which is object identifier number. So I'll use the OID and the dat name from pg underscore database. So you can see the OID of my, this is the OID of my databases. So it is matching with this number. The one is templates 13444 is another one, the Postgres one, and 13434 is my Postgres database. That is what I've connected in. And another was 1390. This is also available. That is why if you create a database, then that Postgres will create one directory inside your data directory. And the tables and indexes are filed on your storage. So I'll exit from here and I'll go inside the base, and you can see I'm inside the base directory, and here is the directory list. If I go inside my PostgreSQL directory, that is 1343, you can see there are many tables and files inside that. So these are the files. So these are the files. These are the database data files, table files, and the index files. So you can see there is the FSM, which is a free space map, and the VMF file also created with your object. So this is the table file. So this is how PostgreSQL basically maintain the database. It creates the object on your database. Like if you create the database, it will create the directory. If you create the table, it will create the file. Again, if a table is a 10 GB, then it will create the 10 files. Basically, it creates a one. So whenever data gets grow, like your table size will gets increased. So when it's reached to 1 GB, and it will create another file for your that same table. That will also name like your main OID, then -1, 2, 3. So far it will create. So on it will create. So this is how basically PostgreSQL create the object on your storage, because the table, these are the tables. These are the tables on your database, but PostgreSQL uses the number in storage. That is what OID in PostgreSQL. That is why Postgres is used the object relational database, because it uses the object identification number to create the object on your storage. So in this module, we'll first see hierarchy of databases, then how to create the database and how to manage the database. Then we will also see how to create the users and how to manage the users. Then we will see what is schema in database and how to create the schema, and what is search path, how to set the search path. Then we see some of the access control parameters in PostgreSQL. Then we will see how to search path to user level or the database level. Hierarchy of databases. So we have seen that in a database, each cluster contains the multiple databases. By default, there will be a 3 database in cluster. Here in the top, you can see clusters. The cluster contains the database. Your cluster may contains one or more databases and the one or more users. and the table spaces. Here, database users and the table space are the global objects. And database contains a schema and catalog and the extension. The schema contains the tables user objects like tables, views, sequence, functions, triggers, procedures. So all the objects are kept inside the schema. Then what is the database cluster? Database cluster is a group of database, the users and the table space. And what is database? Database is a collection of schema and catalogs. And what is schema? Schema is nothing but the group of user object. So why you use schema? Schema is to store group your object like a table, views, functions to group and store it somewhere. We use the schema. So we can create a multiple schema inside the one database. By default, all the database created with the one default schema that is public. So whatever you create on a table, you create on a database, that will be created inside the public schema. That is the default schema for the user of a database. So schema is nothing but to group your object. You can create a number of schema inside a single database. And database is a collection of your schemas and the objects. And you can also create a multiple database in this cluster. As I said, one cluster may contain multiple databases. By default, one cluster contains 3 databases and the users and table space. What is database? So, database is basically a running Postgres server instance can manage many databases. So one instance means we call it one cluster. So one cluster consists of one data directory and the port number and the setup services. And each cluster contains 3 databases by default. That is Postgres, template 0, template 1. And template 0 is the template database that you cannot use it. And template 1 is the default database for default template database for all the user database. And the Postgres is the default database. That is what one your Postgres cluster may contain multiple database. So what is database? What database stores? Database basically stores the database is a named collection of object. It is a collection of schema, and schema contains the table. Database are created with the create database command, and database are destroyed, dropped with the to delete it. You have a drop command, and to list down the database, the available tables in the cluster, we can use the pg underscore database table, that is the catalog table that can be used to view the database list in a PostgreSQL. Or you can also use the meta command, which is backslash and lowercase l to list the database. So create the database. So we can use the create database command. Connect to your PostgreSQL cluster first, then run a create database and the name of your database. You can simply write this and you can execute the command that will be created. But optionally, we can also specify the owner. So we can use the owner command to specify the username, so that user will become the owner of that database. And you can also create the templates, or you can also use the other database name on the template database. So, and you can also set the encoding languages. So whatever the languages you want, like if you wanted to use UTF-8, if you wanted to use the ASCII, there are many methods that you can use it. And the table space. So table space is default table space is pg underscore default. So if you don't specify, that table space is used to. But if you have any user created table space, here you can specify table space your table space name. So we will see how to create the table space in the table space module. But now while creating, you can specify that. Then allow underscore connection. So allow underscore connection is the parameter to you can specify the connection. Then same way you can limit the connection as well. So allow underscore connection, if you wanted to allow the connection on the database or not, you can set the true or false. Or You can use the connection underscore limit to, you can limit the connection on the database. Then is underscore templates. So if you wanted to create the template database, you can create it. So same thing can be created using the create db utility function. The utility functions are kept in the operating system. So you can call it in the operating system layer, the create db, and you can create the database. And you can also use all these options with the create db. Here is one example for creating the database. Here I connected my PostgreSQL instance and I created the database called demo underscore db. You can say create space database space demo underscore db is the name of the database that I'm going to create. And specify the owner equal to Postgres. The Postgres is the default database user, and the owner is the keyword I used. The Postgres user will become the owner of my demo underscore dbu database. So if you don't specify the owner name, if you skip that, then connected user will become the owner. So which user you use to connect the database, that user will become the owner of the database. And you can also change the owner of the database anytime using the alter command. Then the revoke connection. So here I give the revoke connection because by default, if you create the database, the user can default access the database. The user can directly connect to your database. The best practice is to remove the connect privileges from the public. So then in future, if you create any user, they cannot connect to your database. You can restrict the user from connecting the database or logging your database. This is what you can create the database in PostgreSQL. Whenever you create the database, revoke the connect privileges on the database from the public. The public is not the user; it is the role. That role is default assigned to your user. And if you wanted to list the database names, you can use the selected that name from pg underscore database, or you can also use backslash lowercase l to list the database. To connecting the database, we know we have a PSQL tool or a PG admin. We can use that tool to connect the database. So before jumping to the next user, I'll show you that how to create the database. So here I'll connect to my Postgres instance. So yes, I can Postgres. Here I connected. To connect the database, you can also pass here your connect port number. So as I said, one cluster consists of the one port number. The default port number is 5432. And the default user is Postgres, and you need to connect give the database, then the default database is the Postgres. So you can connect to. This is what PSQL. So PSQL is the tool to connect the database. It is a front end to your database, which will allow you to run the command in the database. Or you can use the PG. We'll see that complete details of PSQL and PG admin in the next module. So this is how you can connect the database. Now I am inside the database. So here you can write the create database command. So if you don't know, if you forget the syntax of create database, you simply know only the create database. Then you can use backslash h here and create database. Simply enter. It will give you the syntax of your create database. So that means this many options you can use while creating the database. So let me create a database. Create database. I'll save demo underscore database. Okay, because I have a demo underscore db already created. Demo underscore database. And here you can specify owner Postgres. So my current user Postgres, or if you have another user, you can specify the owner. If I remove this and if I create, the connected user will become the owner. That which is connected user? In my case, it's the Postgres is the connected user. So and we can use the owner here to specify the username, so that user will become the owner of your database. And if you want to specify templates, you can use template. So here simply use the templates, and which one is template database. So let's say template 1, and you can also set encoding. You can also use the table space. So if you wanted to use the table space, you can use a table space is equal to pg underscore default template 1. So it will create the database. You can see database is created. So now if you want to release the database, we can, as I said, you can use \l. So this is the one command, \/ and the L command, which will list the database. You can see I have this many databases. So these three are default databases, which is these last three databases are default. Whenever you create a cluster, you will see these databases in PostgreSQL. And template 1 is this templates is the default template for your newly creating the table space. Newly creating databases. Whatever you new create a new database, this template database is the default one. And the template 01 is the internally used. You cannot use this template 01. And even you cannot connect. But using the template 1, you can create some object inside that. That will be created automatically whenever you create a new database. And Postgres is the default databases. You can use it for your application purpose, any purpose, you can use this database. And these all are I created databases. So these are manually created. So same way I have created this demo underscore database. You can see owner is a PostgreSQL and the encoding is UTF-8, and that is the correct and language types, and the access method is empty. So now the user can connect my DB also. So while you are connecting, you can exit here and you can specify your database name. So instead of database, you can use -d here and your database demo underscore database. So it is connected to my demo underscore database. This is how you can create the database. And another method to create the database is create DB. Here you can see I'm executing this create DB in the operating system. I'm not connected to my database. I exited from the database. I have not connected my database. I simply executing this on my Unix layer. This is the operating system prompt, and I'm executing this. And if you want to check the option, you can use -here, which will list all the available option. You can see same option is available here also. You can use the same option to create the database. Let's create another database using this option, create DB. And here you need to specify your cluster information, the connection string, which is port number is 5432. And I'm going to use Postgres user. And if you wanted to use the table space name, you can table space name. And you can use echo encoding set. You can set it. You can set the local option. You can set it. And if you wanted to set the owner, you can use -o option or -owner equal to owner name. Let's create the -owner and set the owner name. So again, here we'll set the Postgres is my only user. I'll become that is the owner of my database. If you wanted to create a templates, you can use the template equal to templates. So same thing, I'll use the templates, and my template database is the template 1. Then I forget to specify my database name. So what database I wanted to create here? Demo underscore database underscore new. This is the database I'm going to create, and owner will should not be here. Should be start from the start before the my port number. The name should be here. Demo underscore database underscore new. So create DB, and this is the database name I'm going to create, and -p on which cluster? The 5432. and using which user? Postgres user. And who will become the owner of my database? Is the Postgres user. And which template database is for the creating the database? The template one. We can also use some other options like here it's given. These are the options you can also use it while creating. So I'll simply press here enter to execute this. It will connect my cluster and create the database. You can see this is executed. Now if I connect to my database, let me connect my database, and if I run l-l/l, you can see the demo underscore database new is created. Now if I exit here and if I change here demo underscore database name, I'll connect to new database. You can see you can connect. So this is how you can create the database in PostgreSQL using session level and the operating system level. So same thing, you can delete the database. To delete the database, we can use drop command. So if you wanted to see the help, check the help of the database, you can use \h and the drop database. It will give the syntax. So only you can run if exist command and you can simply drop it. So to drop, I'll drop my previously created database, that is demo underscore database. Drop database demo underscore database. That's it. But if any user is connected to this database, then it will throw a error. First, you need to disconnect that user from the database and you can drop the database. So the same way, we have a utility function called drop db on the operating system. Drop db. So you can see the help of the option. So here is the help. There's many options you can use. Only the two options are there. So to drop the another database, you can use is instead of the create database, you can use here drop db and which database I have to drop from database new, and using this port, and this information is not required. So it will connect to this instance and delete this database. You can see now if I connect my cluster, so using the demo DB, you can see it is throwing error. Demo database new does not exist because I have dropped here. This is what you can do. So now I'll use my default database, that is Postgres. So you can also manage the database by editing the databases. So modifying, you can use also alter database. So if you wanted to change the database name, you can also change the database name. Right. So if you wanted to see the option, you can run \h alter database. So which will show you the option. So this many options you can use. You can set the allow connection or maximum connection, max connection, or you can create the templates, or you can rename using the alter statement, or you can change the owner of the database using the alter statement. You can set the table space using the database, or you can also set the parameter using the alter database command. You can reset the database parameter. You can reset all the database parameter using the alter statement. These commands can be used to manage the database. Let's say I have other databases here, demo db underscore dir. So I'll use your alter database demo db underscore dir to rename to demo underscore dir. So db to db I underscore dir to demo underscore dir. You can see now if I list, it is the database is renamed to demo underscore dir. There is no db underscore dir. That is renamed to demo underscore dir. You can connect demo underscore dir. So like that, you can change the owner of that. You can set the parameter for the database level. This is how you can create and manage the database in PostgreSQL. So next is the users. What are the users? So database users are completely different from the operating system users. So just keeping in mind that the database users are completely different from the separate from the operating system user. There is no link between operating system user and the database users. The database users are global across the database. The database users are the global object in the cluster. So why I am saying it is the global? Because the user can own any object. User can own one or multiple databases. User can own the schema. User can own the separate specific object on the database or a schema. That is why users are global object in the cluster. And username must be unique and must not start with the PG. So you cannot create a duplicate name with a username. Even you cannot create a database with a duplicate name. So that username must be unique and it must not start with the PG. Why PG? Because PG is used for the database internal. That's why you should not use the PG for your creating. Your username must not start with the PG underscore. Every connection made to the database is made using the user. So if you wanted to connect the database or any cluster, we need a user. Without the user, you cannot access your database. The user is the one user port number, database name, and the IP address of your system. These are the four mandatory fields to connect your database. Without this, you cannot access your database. That is why user must be your connection you made to the database that's made using the username. And the Postgres is a predefined username in the default data cluster. So whenever you create that instance, so while installing, it will give you the option to choose the super user. But if you don't specify the username, if you use the default one, the Postgres user is created in the background, and that will be the super user for your cluster or a root user for your database. So as I said, that super user can be specified while initializing the cluster, while initializing the initdb. So we have seen that initdb. So utility function, while initializing the cluster, you can use the -U to specify the username. So that user will become the super user for their cluster instead of PostgreSQL user. So or you can use the default PostgreSQL user. And this is a predefined user as all the privileges with the grant option. So this is the root to user. This is the super user for the PostgreSQL. This user has all the access. This user can do anything. If the user is a super user, then he can do anything on the database. He can access any database. You cannot restrict any privileges from super user, because if the super user, then he can do anything on your database. This is the super user, is the root user for your cluster. And you can create the multiple super user in a single cluster. There is no limit, you can create the multiple super users. To create the user, the same way we have a create user command, SQL command in the database. You can use the create user or a create role SQL command to be used to create a new user. Only super user and user with the create role privileges can create a new user. So all the user cannot create. If you are a super user, then you can create a new user. Or if you have a create role privileges, the create role privilege can be provided to the user. If you have that, then you can create the user in the database. Otherwise, you cannot create the user. Normal user cannot create the new user on the database. To create the user, you can check the \h and create user command to for the syntax. So you can use here create user and the name of your user, and you can use super user. So if you provide the super user, that user will become the super user. And if you want to remove the super user privilege from that user, you can use alter user username and the no super user. Or while creating also, if you don't want to make it the super user, you can also use the no super user. or you can simply skip this two option as well. That user will become the normal user. Then, as I said, if you wanted to provide the create DB privilege to the user, then you can use the create database. That user can create the database. To remove that privilege, no create DB. So to provide the create role privilege to the user, you can use create role. To remove that, you can use no create role. The same way, if you wanted to inherit the feature from the other user, you can use inherit or no inherit. Same way, if you wanted to allow the user to login privilege, you can use the login. To remove it, no login. Same way, if you wanted to create the user for the replication purpose or a backup purpose for performing the backups, you can use the replication privilege. To remove that, no replication. Like if you wanted to bypass the role, you can use the bypass rule and no bypass rule. And the connection limit. If you wanted to set the connection limit for the user layer, you can also set it by setting the connection limit. And if you want to remove it, you can use no connection limit for the user. And you can also set the password using the encrypt option or the simple password. You can set the password option and set the password in a single quote. And you can also set the password null using password null. And you can also set the validity for user. You can set the time and you can date and time for the user. Once that is reached, the user will be automatically expired. So that is what these many options you can use while creating the database, also while creating the user. So create user. So the another option is that the create user operating system utility function. So that can be executed in the operating system same way we like create DB database. You can use all the options with the create DB as well. Using -c, -d, capital D, we can use all the, if you wanted to make super user, if you wanted to create the create database page, create role. So all the options we have discussed in the previous slide that can be used with the create DB utility function that can be executed in the operating system level. Let me quickly show you the user demo. So if you wanted to create the user, you can see /h and the create user. So here is the syntax of the create user. So this many options you can use while creating the user. And for listing the user, so if you wanted to list the user, you can use \d and the u, which will list the available user. You can see in my case, I have only the two user. One is the Postgres, there is the default super user, and another is the demo user, that is the normal user. So now, if you wanted to create the user, let's say create user and the username demo underscore u1, and I'll say password, and I'll set this A, and I want to provide the login privilege, login. So simple, the user is created now. So if I run du, you can see this is again the normal user. This user has a login privilege, that's it, no other. If I connect with this user, so I'll connect the database in the Postgres and demo underscore u1, you can see the there is a connection authentication error is coming. So because of the PostgreSQL pg underscore hp.conf file. So I'll quickly enable this because I'll show you why it is in security module. PGSQL 13 data pg underscore hp.conf file. Here is the issue actually. So we need to change set to peer set to DMD5. Let me share the password every time. So PSQL and select pg underscore reload underscore conf. Sorry, select reload underscore conf. Select page underscore reload underscore conf. There is a typo mistake again. So it is reload. Now I will connect again to the here. So now if you wanted to see DU, I have a created user, and if you wanted to switch to demo underscore user, so you can see Postgres database. So instead of exiting from the session, if inside the session also you can change the connection by providing \c, and this is database name, and you can use demo underscore user u1. There is a username. The database name comes first, then username. So if you enter, you can see it is asking enter password for the demo user. I'm entering the password. Now I am connected. You can see you are now connected to the database PostgreSQL as a user demo user one. So as I said, this is a normal user. So if I try to create the database, so this user does not have a privilege to create the database. Here you can see create database db1. The permission denied to create the database. So by default, the user does not have that feature. So if I create the user, create user u1, you can see the permission denied to create the user. You cannot create the user. That's why I said normal user cannot create the database, cannot create the database. So I'll again switch back to my Postgres user. So now I connected to Postgres user. Now if I list the user EU. So if you wanted to create the user with the create DB privileges or create user privileges or with the super user. So let me create user demo underscore u2, and I'll say super user and password. Again, accept the password for this user, and now I created the super user. You can see, so once it is a super user, then you can do anything on the database. So I'll connect my Postgres database using the demo underscore u2, that is a super user. So enter the password. Now I'm connected as a user. Now if I create the database here, if I run create database command, I can create database because I'm the super user. I can do anything. I can create user because this, see, the user is also created. So if you can see \l, you can see database is created. If you see du, the user is created. And you can see demo underscore user 2 is the super user. So your super user is by default for the create role privilege, create DB privilege, replication privilege, but all the features it comes by default if you make the user super user. Here I will connect back to my Postgres user, and I'll remove that super user privilege from the user. To remove this, you need to use alter user username demo underscore u2 no super user. To remove this, you need to simplify no super user. Simple. My user is altered. Now I'll connect to my same Postgres database using demo underscore u2. So you can also reach here. You can see that super user is gone here. There is no super user. Earlier it was showing the super user, but now there is no super user. Now if I create database db10, it is showing error permission denied. So this is how you can provide the, so if you wanted to only to give the privilege to create the database, you can give the privilege like only the create DB privileges. So same thing, you can also provide like create role privilege. You can provide the create role privilege to the specific user. So, and you can also remove this privilege by altering. So this is how we can create the user in the database using uh, PostgreSQL. The same way, there is another utility function is also available, that is create role. Create user. So if and same option can be used here also. You can see this all the options we have discussed that can be used here also. So let's create the one user using this. Create user and the username demo underscore u3 and connection string 5432 and hyphen capital U to specify my connection user. So I'm going to use the Postgres user because he's the super user. So that's it. I'll not enter. So it's asking password. I enter the password. So it is created. Now I'll run PSQL. I'll connect my database. And if I run du, you can see demo underscore u3 is created. So you can see demo underscore u3. So this is how we can use the create user. The same way we have create. So we have drop user. So you can also use the drop user to delete the user. So delete the user, I'll use same command which I created. Same thing I'll use here. Drop user and it's asking password and that. Now if you connect, you can say du that user is been deleted. So that command can be used here itself. So drop user and the username the demo underscore u1. So that's it. The user is deleted. If user is using or if there is a dependency on the user, then it will throw a error. So if you have created some object using that table, let's say you have created the one table using that data, that user, then if you try to drop it, it will throw you the error because there is a dependency. You need to fix that first, then you can delete the data user. So this is how you can create the user and create the database. You can alter the database, you can alter the user as well. So you can use alter. So if you wanted to see the syntax of alter, you can use backslash h and the alter user. So you can use the alter user. So for altering, you can also set this. You can make the user super user by altering. You can make the use, you can remove the privileges from the user by using alter. Then you can use the user-wise parameter using the alter. So if you want to set alter user demo underscore u2, no login. So I'll remove this login privilege. Now if I say PostgreSQL and demo underscore u2, and if I try to connect, if I enter the password, you can see the permission is deleted. Permitted is no login. So this is how we can use the alter command to modify the user privileges. Or you can also rename this user. So using alter user the demo underscore u2 rename to new name that you can see demo underscore u5. I'm renaming an existing user. You can see that user is renamed. So to list the user, we can use the \du, or we can also use the select star from pg underscore users. So pg underscore user. This is also you can find the user list of the username, or you can also use \du. So pg underscore user is a catalog table. You can see here. You can see this whether it is a super user, whether this user has a privilege to create the database. You can see user create database, use create db. So demo user does not have that privilege because it is false. So demo user does not have a create use, not the super user. You can see it's a false, and replication privilege is also not available, and bypass routes is also not available, and the password is always encrypted, and there is no valid date is set. So you can see the Postgres is the default one, and this is the OID of the user, and this is the Postgres default user. You can see all the through here because it is the super user. This user has got all the privileges in the cluster. So he is the master user, or you can say root user, or the super user. And U2, and also you can say it is a normal user. There is no additional privileges is given to this user. So this is how you can manage, you can view, you can delete, or you can say you can manage the users in a Postgres. So in this model, I'm going to cover introduction to PSQL, so which is we already used to connect the database. So I'll give you the more details of the PSQL command, then connecting to the database, how to use the PSQL to connect the database. Then we will also see the command line parameters, and there are some meta commands in PostgreSQL, PSQL. We will see what are those, how to execute that meta commands to view the object on database. Then we will see graphical tool as well. PSQL. So PSQL is the name of the PostgreSQL binary. It is a binary file. Whenever you install the PostgreSQL, that file also installed in your server. So by default, that PSQL files kept inside your home directory. In a Linux, so it will be by default, it goes inside the user PSQL 13 bin and PSQL that bin directory. On a Windows, C program files PostgreSQL and the 13 and bin. So PSQL provides a terminal-based front end to PostgreSQL server. It is a tool which is basically used to connect your PostgreSQL server. So you can use this tool to connect any PostgreSQL server, not only like the default installed one. If you have any other remote server, you can also use the PSQL connect. PSQL to using the PSQL you can connect to a remote server as well. Then it enables you type the query interactively. So you can run our meta commands, you can run your SQL queries, you can run your complex SQL queries. So all the tasks you can do using the PSQL. And to identify or to locate your PSQL on a server, you can simply say which PSQL, it will show you the path of your PSQL. And to connect the database, you need a port information, which is the mandatory information to connect your database. Without those, you cannot access your database. The one is the port number. This is what we call it connection string. So without this information, you cannot access your database. The one is the port number, which is by default 5432, and the username. So without the user also, you cannot access your database. And host name. So host is the where your Postgres server is installed. So if you are connecting on the local machine, then you can skip that host. But if you are accessing the remote server, then you need to provide that server host name or the IP address. Then I will find D for database, for which database you want to connect. So if this will connect to your database and if that password is enabled, then it will prompt you to enter the password. Once the password entered, you can see the PostgreSQL session that is marked as changes. And that is tells that you are inside the PostgreSQL database and where you can execute the command. To check the PostgreSQL version, you can simply write a select space version, so which will list to show you the version of your PostgreSQL. So as I told you, that database name, host number, port, and the user. These are the mandatory information to connect the database. Without that, you cannot access your database. You can also use information on your system variable. So in the Windows, you know, we add a system variable. Same way, you can also use create in a Oracle, sorry, in a Linux version. So in a Linux also, you can create a variable. That variable name is PG database, PG host, PG port, PG user. Inside the dash underscore profile, or you can globally also you can run. So what is the use of this setting the variable means? Every time you use the PSQL, you connect to a database. So every time you need to pass the your all the information that is database, host, port, user. But if you set the invariant variable, you don't need to call it every time. You can simply write the PSQL and you can enter. It will read the all the parameters from the variable. So based on the variable, it will connect to your database. And PSQL has its own set of commands allow all of which start with the backslash. So PSQL supports that its own command which starts with the backslash. So these are is no way related to SQL command which operates in the server. So which is not related to your normal SQL command. It is separate available in the PSQL prompt only. You cannot use this function using any other tool. Only the PSQL will provide this option. So some command accept the pattern. This pattern is modified in regex 3 point using the star aura question mark. And double quotes are used to specify the exact name. So ignoring all the characters and the precision in the case. So double quote are used to pass our specify the special character, our exact name. So you can also use using a PSQL. You can also use icon F to provide the find name. So which will be executed in the database. So if you have any SQL file where you are stored the SQL queries, you can execute that queries using the PSQL in the PSQL command by providing the icon F and your file name. That will be executed inside the server. And this is also the one way to restore your SQL file. And I can see for the command, you can pass the command in the PSQL terminal also. Without logging the database, you can see and the command that you want to execute. That will be executed in the database. And hyphen help to check it will display the startup option. And hyphen version to display the version of your file. So here I will show you that PSQL one by one. So first I'll connect to PostgreSQL instance. Here I'll connect to the PostgreSQL instance. Here I connected to my PostgreSQL instance. As to PSQL, if I connect to PSQL, you can see I can connect because it's taking the default variable. Now if you want to see the which PostgreSQL, you can see which and PSQL. So you can see it is taking from my root directory. So if you run L, it will also show you some other command which is taking the PSQL after this. So basically PSQL reading. So if you want to check the version of PSQL, you can see icon version, which will tell you the version. You can see I'm using the PostgreSQL version. You can also use PSQL with the icon help, which will lead to all the available options. And these are the options you can use in the PSQL. So this is the general option, which is command.
As I said, you can run the command on it, and the DB name, icon D to provide the DB name, icon F to provide the file name, which will list the database in the server, and you can use icon V to check the version or icon enter version. Then these are the input output method you can use. So icon E to query, listing the query icon to new deadline. So this is the connection in data access. So these are the information which is important to connect the database. So basically we connect the data, you need a connection information, that is first is the host name. So if you have a connection in the local host, you can say local host IP control 7.0.0.1, and icon P is the database port number, which is by default database runs in 5432. Then icon capital U to specify the username, that is Postgres, and icon D to specify your database name. I am going to connect the database in Postgres. So here you can see I'm connected to Postgres. So if you wanted to list the available database, you can here use icon here. So this will list the database. That's it. I have a total 3 databases in my cluster, which will display here. So same way, if you have any function, if you have any SQL file, you can also execute that. Here I'll create one text file, text.sql, and I'll write here one command, that is select star from PC underscore database. So if you have a file, like SQL file, which is basically a create table or any command, like SQL file. So your database command file. So if you wanted to execute this file on your server, then you can use the PSQL icon F and the file path and the file name. So that will be executed. You can see that file is executed. So this is how we can use the icon F option to provide execute that file. How do you want to run the command? So if you don't want to pass, if you don't want to log in the database, you want to run one single command, icon C, and inside the double quote, you can write select star from PC underscore users. So that's it. You can execute this query. So that's the relation does not exist. So it can be the underscore user. So you can see the user information. So if you provide the command in a double quote, this will be executed. This is called command. You can run this command in a PostgreSQL. Next, we have a mini meta command in PostgreSQL that will basically help you to list down the database information. So let's say that I connect to my Postgres database. Now, if you wanted to see all the meta commands, I don't know how many commands are available. So if you wanted to see, you can see the action and the question mark. It will list you all the available options. You can see that copyright, so Postgres and distribution term, and the cross tag view. Then you can see there are many important things that tell you. These are the important things that the backslash f, which will basically tell you that if you wanted to see any help of your command, which will show you all the available options in the command. And icon E and the file name, which will allow you to edit that file or query. And if you want to edit the function, you can use icon E and the function name. If you want to edit the view, E and the view name. And the key to show the content of the query buffer are to reset that. And icon S and file. If you want to see the history, whatever the commands you have executed on PostgreSQL on the terminal, if you wanted to see all that list, you can use the backslash H. And the same way, icon W to write the query buffer into a file. And same way, we have a copy file, which will basically help their copy option, which will basically use to copy the data. I'll tell you that how to copy that in a copy data module, but now there is a command called copy and icon hide. So the same way I created one SQL file. So you can also execute that file inside the session inside the database using the \i and that file path and the name that will be executed in the database. I like that if you wanted to, create the output of your command, or if you wanted to store the output of your data on output of your query, you wanted to store it on a file, you can use -o and the file name where you wanted to store. So same way you can use the details, these are the statement details, condition you can also use. And more interesting part is in this one is there is a many meta commands which will help you to basically read the database information. You can see there is the information part where it is showing the /b, SCA, and AP, AC, AD, DDD. See, these are the shortcut commands which will help you to reach the database object. So if you want to release the all the objects, you can simply take the first D and the capital S. Which will list all the available, tables, views, sequences. And the same way DB. So you can simply, whenever you are free, you can simply log in and read this, which will do all the available options. For if you want to release the table, you can DB. If you want to release the user, DU. If you want to release the database, /L. And you can also add a plus symbol with all the commands, which will basically display the more information of that object, like the owners and the description and the size. So these are the options you can use connections. These are many options available. So when you are free, just go through and execute the one by one command and see the output of that command. And there is a clear description also given. You don't need to confuse about the command because there is a clear description also given by the PostgreSQL. So let's say that if you want to use the object, that you can see yes, and you can see there is all the data information. These are the Postgres internal tables, like you can see here, list of the relation and the type, which is the table, and which will also list the fields. So these are the system information. And if you want to check the user created tables, you can see the /t, which is these are the tables that you can create manually. If you want to see the more information, you can simply add a cut symbol and you can check. So you can display the permission, participants, privacy, and the description. So if you want to see the table structure, then you can see the /t and the plus thing, and you can type the table name, the object name, and press enter. It will show you the other. You can see this table contains only the one. So you can show another table, T plus field, and the table name. You can see these are the column names. These are the list of the column names in the table. So these are the information you can view using the meta command. Not only this, if you have a you can use the object and table D. And there are all the commands you can one by one you can test it, run it, and there is no problem when for running this command because it's all displaying the data. It will not modify to our data. To list the database, you can see that /L. So it will list in the database. So if you want to do the N, which is the schema. We have seen that how to create a schema. So this is the schema by default. Same table space db and other there are many commands you can if you want you can again run with the command. So as I said, if you want to execute the command which I created previously, you can use icon I and the test name, that is the test.sql. See that command will be executed in the database if you run this script. This is the script I executed. And if you want to now just say that if I wanted to execute this command, you select star from easy underscore statements. Sorry, easy underscore database. So I wanted to store this output to my on file. I don't want to put this page here. So if you want to delete, you can use backslash o, that is for the output, and you can say database dot txt. So I execute it. Now I run the sort of start from previous statement and I exit. You can see there is no data display. Now again I run backslash o and I enter. Now I'll exit here and here I'll see that what name I given database.txt. You can see the data is stored on my database text file. So this is how you can store it. If you wanted to take the output of your command, you can use the move. It will store that in your text file. Not again file. So when I come back to my instance, yes. So if you wanted to do setting, you can see the actually question mark which will use to action. So these are many options you can shift that which you can use the object, list information table, type, rows, views, extension, databases, event triggers. You can see it is clearly given. If you want to see the index list, role information. So if you wanted to see the user information, it is like DU. This is the meta command related to the users. This is how you can execute the commands. There are many commands in both this meta command. You can run one by one and you can fix that. And you can also set the variable using the set command. So set command is a variable to set the parameter as well as set the variable. And if you want to delete that, you can use unset and the parameter. And there are many special variables available which is the auto commit, because by default Postgres is committed. Auto commit is basically to enable or disable the commit. So in PostgreSQL the commit is by default enabled. So if you do some transaction or if you do anything changes, that is committed. That means you need to explicitly type commit statement here. But if you are executing any statement within inside a transaction, like in a begin and end, then you need to send a commit out all that state. So if you wanted to turn off the commit, auto commit on the session level, then you can use backslash setting and the auto commit off, which will turn off the auto commit option for the session level. And once that is set, then on that session you need to tell that process to whether you need to commit the changes or roll back by using the commit and the rollback. So there are other options like encoding mechanism, file or error rollback. These are the other variables are available that you can use in the transaction. So like that, if you want to auto commit, give the set and you can see this many options you can use. That's the auto commit which will turn off the auto commit. So if you want to enable, again you can enable or you can use the default. So on. So it should turn it on. And this is again only for the session log. And you can set the DB name, you can set the user, you can set the version for the session log. If you don't know any object name in a database, so you can use the double tap, which will autofill. Now like start, or if you don't know the command, here I'll write only the SQL. The other part is automatically done. So that is what autofilling option. And select star from if you don't know the name of table, entire table, you just know the first or three characters of name, you can run EP slash and you can run the, or if you say PG database, you don't know the full name of that, you can simply say DA and database is out of it. Or if you want to list all the available tables which start from the PG, you can write a PG underscore and simply try double tap it. You can see the 133 objects. Here these are the objects that are available. So this time start for the piece. Or if you don't know the table name, you can simply click here. You should show the schema name. Let's say I have a complete schema, token, and these are the tables available on my complete schema. And this information schema, PG catalog, PG toast, public. These are the schemas. These all three are internally used, and this is for the user use. That is the first. And these are the three tables available in my server. So this is also one of the nice feature which is auto tag. You can disable it while logging using the -n, which will disable the auto tagging option if you don't want it. Then as I said, the --t, which is a meta command, which will list the information. So if you want to see the index, you can use IE. If you want to see sequence, you can use F. If you want a table, T. And if you wanted to view the view, then V option. Then if you wanted to list the system object, then capital F. With the D, you can run this all with the D option, which will list on all the objects. And the plus, as I said, the plus is always used to display the more additional information like the description and the size and the ownership. And the --L is to use to display the list of the database. And icon bracket N option to display the list of the schema. And icon F to list the functions. Icon D to list the your table space. And connection info, which is basically show the connection information of the which database, which user you are connected. So con info is the command which will list to show you the if you don't know which user you are using, which user you are connected, you can say you are connected to the database Postgres as a user PostgreSQL via socket, which is what. So therefore, and there is a q to exit from the PSQL session, or you can use the control D option also. You can use the control and D, which will also log out the session. Then --cd, our explanatory mark. These are actually operating system command, so you can also use it. So cd/tmp, if you want to print the tmp, you can use it. And you can use --explanatory mark and ls, if you like to run the ls command on there. Yes, you can do the ls, then you can run direct. Or if you want to go back to the operating system level, you can simply use accelerated mark. It will take you to the session script, which is over here. You can run any command ls cd/tmp. So here you can run all the operating system command. So if you wanted to come back again, you can use the control D, which will take you to the previous step. So you can run here any command /ls/exclamatory mark using, and you can run ls cmp, or you can say /ls standby. I have a standby directory here. You can see it listed all the records of standby, but I am inside my PostgreSQL session. So if you wanted to edit any file, you can say icon name, and let's say that I have a test underscore SQL file, and edit this --e and test underscore. You can say test. You can edit and you can so let's say that I'll add an entry here using limit 1. It will only display the one record. Now if I save it, that file will be executed in my database. This is how you can use the PSQL session. Then as I said, question mark, which will help you with all the available options. And as I said, one more important thing is that if you don't know the any command, like you don't know how to create the table, or if you don't know how to create the database, you can simply use the --h, and you can say here create database. It will help you create the database. You can say the create database and the name of the database. You can say create database name, and if you want, you can use this option. That's it. So same way you can use create database. If you don't know how to create a table, you can say create table. It will tell you that how to create a table. Create a table, and you can use a global, temporary, unlocked table, and the table name, then the column name and the data type, and other constraints you can use it, and then finally close it. And these are the other options that you can use for creating the table. So this will help you to list the available option or the basic syntax to list the syntax of your command. So that is what command line does. So whatever you can do, you can run any complex query in a PSQL. So let's say that you have connected here and this is my session. You can see here database there. If you want to switch to other database, you can use it here and you can connect to another database. Let's say template 1 because they are connected to template 1. So it's to short form to connect. To which connect this connect. And if you want to change the username, you can also change here username. That's there at user. Now I'm connected to template 1 using that user. First it comes to the database, then the user. So now I'll connect to that this user. Okay, now here you can write any query. So if you want to select the star, any complex query, anything you can do in there. This select star from test underscore. That's it. Test underscore signature. That's have a table with that. You can delete the data. You can do any complex query or you can do any dbms, DNL, Psql statement inside your PSQL session. So this is all about the PSQL command line. This is what command line we call it because everything we need to write here. And then Postgres also support the GUI, which is a graphical tool. So Postgres is graphical interface to help you the big open source database users to manage, manipulate, and visualize their data. So whatever you have listed down, whatever you have seen, everything can be manipulated and created. How you visualize the data tool. That is what graphical tool is. So graphical tool is heavily used because that is user friendly. So why graphical tools are used? It is a shortcut which makes easier to use and much easier to learn from the user and offers a great visualization to help you to interact your data. You can remotely access and navigate another database server. This window-based interface makes it much easier to manage your PostgreSQL database and easier access to files, features, and the operating system. Always it is not only the database, if you have any application or anything, if it is a graphical, then it is very easy to access it. But if it is a command line, then it is very difficult. You need to remember all the commands to run it. But in the graphical mode, everything will be in front of your eyes. You can only be just to choose that option as such. So, what are the tools are available? Let's say, first is the PC admin. So, PC admin basically comes with the PostgreSQL. If you install on a Windows, the PC admin also installed with that. Yeah, Linux also will install, but you cannot open it because if you are using the command line. So, but if you want to install the Windows, there is a PC admin primary available for the Windows and the Mac OS and the Linux is also available. You can download it and install it. Installation is very simple on a Windows. You can simply click next and it will just install on it. Once installed, go to your program file and open. So this will be the first screen you will see when you open the PC admin. So here why the Postgres user love the PC admin. So PC admin creativity and edit the all column common Postgres objects. So using the PC admin, you can do all the objects. You can create, you can delete, you can manage. So all the things you can do using the PC admin. And there is a quick graphical query planning tool as well, which will help you to execute the query. And there is a dashboard to let you monitor the server activity such as the log, the connected session, and the transaction. And since the PGP is a web application, you can deploy it on any server and access it remotely. And the PG admin UI consists of the detachable panel that you can arrange according to your space. And procedure language debugging helps to debug your code. PG admin has a portable version using which you can move your data between machines easily. So let's quickly see the PG admin. Here I already installed the PG admin. To open the PG admin, go to the URL file and here you can see I have a PG PostgreSQL and the typing is installed on my machine and then open the my PC admin port. This will open the PC admin in a web browser because it is a browser based tool. To install this, it's a very easiest thing, so I'm not going to show you the installation. You can just download and install it. So you can go to your PostgreSQL org website to download it, or you can also download it from any third-party website. So other than there is another tool. So by the time I'll cover another time. Okay, so it's connected now. You can see it is opening. So it will first ask you to enter the system password. I enter my system password. Here you can see it will be the first screen. And if you click here server, you can see this will lead to all the available servers. So this many servers I have created in my instance. If I click PostgreSQL 13, it will ask to enter the password. So I enter the password. It is a wrong password. Let me and another password and another password. Okay, so it is connected. Okay, so you can connect. It is connected. The first screen I'll show you. This is the dashboard. So this is where you can monitor your database. So you want to click your cluster name, suppose this there, and you can see there is the first server it is doing this server sessions. It is showing the total number of sessions, connected sessions, the total session, and the active session, and the IPM session. You can see I have a one session that only connected to my server. And the transaction per second, you can see there is a one transaction per second. And the tuples in, which is insert, update, delete, and a tuples out, which is your select statement. And this is the IO blocks, which is IO information of the storage, how many records are being stacked on the server. And if you scroll down, you can see the session. So these are the session information of the database. Let's see, I have only one session. These are the background activities services. So user session is the only one. You can see database, user I use PostgreSQL and the PG admin. This is the one session. And this is the part of the parameter. So all the configuration parameters can also be seen in the PG admin. You can see these are the parameters that are available in my PostgreSQL. You can scroll down and scroll up. And the prepare transaction and the logs. If there is any logs on your database, you can see the log. And this is the prepare transaction information. There is no prepare transaction. So these are the information is available in PG admin. You can simply monitor your database using the PG admin. And how to connect your instance. Let's say that you can, here I have this many servers. These are all manually added. To add your server, you need to right click on the server and right click create server. Or you can simply click on the object create server. So which will show you another window where you need to add your name. So this will be the user name. You can name type anything. SQL underscore testing underscore server. And if you wanted to group it, you can group it, simply leave it, and this is the host number. Where you need to type your system IP address server you are going to connect. So I am using a local host, and my port is 5432, and database I am going to connect Postgres. The user I am going to use PostgreSQL, and I will enter the password. So if you wanted to save the password, you can click the save password, and simply click the save, which will connect to your server. You can see there is a PostgreSQL testing server added. If I click, this is a monitoring window. And if I scroll down here, if I click here this arrow mark, it will show you my all the listed databases, logins, and the tables. So if I click on the database, you can see I have a three database on my local list, which is DB1, DemoDB, and the PostgreSQL. It will not show you the templates database, it will only show you the normal databases. And user and roles, you can see I have a different user and the table space, you can see I have a two table spaces. So here is the database. As I said, you can use the PG admin to create it. you can use the PG admin to manage all the things that you do on a command line. So if you wanted to create a database, you can right click on the database and create database, or click on the database, click object, create database. And here we simply give the database name, that is demo underscore pg2. And you can choose the owner for your testing. So in my case, okay, I'll give the okay. And if you wanted to type the comments, let's say that DB for application. So this is for the application purpose. So I create a new application purpose. And the definition. You can choose the encoding and change it if you want to skip default. And the templates, if you wanted to create a templates of any other data, you can choose it, or you can leave it. And the table space, if you wanted to put this data in different table space, you can change it. And in my case, it is only the default, that it will go inside the default. And the collision line, then you can set the connection. Here is the security. You can use the grant review for the database. And the parameter also you can set. Then the advanced schema restriction, you can see in the SQL, it will generate the create database demo with the owner encoding limit, which is the unlimited range one. And the command. This is the command for the database. So if I click the save, this command will be executed in the database. I'll simply click it and it will create a new database on my server. So same way you can use to create a user, you can create a table space using the PGSP. So you can see that database is created, demo underscore pg. So if you click on the database, you can see here is a schema language with foreign data extension. So if you want to do schema, you can see schema. So by default, there is a public schema. Inside the schema, you can see all the objects. So you can use the PG admin to create all these objects, all the schema as well. So if you wanted to create a schema, you can simply right click on the schema and the create schema. Or click here and object create schema. Here type the schema name, and if you wanted to change the user, change the user. If you want to do any security part, change it and save it. So I'm not going to create it. The same thing. So if you want to create a table, you can click here, right click, create table. Our object create table. So trigger, type, view, all these objects can be created using the PG admin. So this is the tool you can use it for managing your database. This will help you to execute the command, execute the, all the operations. So if you want to write some commands, so if you don't want to use graphical, you can write a complex query. If you have to write some queries on your database, then here you can simply use the query tool. There is a tool, and here is the query tool. You can simply click on query tool. It will open the new window here. So here you can write your own query. So let's say that if you want to write a select start from PG underscore database. So if you want to execute this command, you can simply here execute that. This will execute the command and display the data here in that. So this is hot my database. Please, you can see. And use the explain plan. This will generate the step, but there is no explain part of it. This is saying the successfully run code very further. It runs in 1 second. And the notification is simply. And you can see this is the connection query tool, and this is the open file. If you enter to open the file and execute it, here you can see. If you enter to save the query, you can save it, and here is the save data changes too. If you make any changes on this data, so if you enter to apply this, you need to save here. And this is to search the object, and this is to copy the accessory, then this is to delete, this is to edit, and this is to filter the data, this is to execute, this is to stop the running query, or cancel the query, And other option like explain. So if you enter to run the explain of this, you can run this. It will show you the explain output. You can see this is the explain. You can see the sequence of scan, and this is our commit and rollback. If it is commit is disabled, then you need to put the commit after the state. And here we can also see clear access, and here it is. If you want to download this query output on a CSV file, you can simply click here. It will download the file. You can see this file is downloaded here. It will create a CSV file. So these are the options are available in PG editing. You can use this. The statistic information that we are explained. Then other information like I hope you know that how to create the table, and also you can right click create table, which will open the table, and here you can fill the table. You can simply create the table name, that is test underscore T1, and you can use the owner. If you wanted to change the owner, you can say, and where you want to go, which schema you wanted to create. You can see the schema name in my case one, and you can place it on a different table space. You can choose the table space. In my default, it's the default one. And if you want to make a partition table, you can click there yes. So it will create a partition. You need to cover the more information for that. And here you need to add a list of your columns. So to add here, you can simply click on plus symbol and the name of your column, that is, let's say that ID column, and using the data type that is int, which is beginning. And constant, I will use the primary key, not null constant. And if you wanted to create another column, simply create a table, create it, that is the name, and I'll say varchar, character variable. Suppose it is a character variable, and I'll say that not. Then advanced option is there. You can create here a number of columns as per your requirement. And the advanced option, you can use role policy. These are the options you can use. We'll not talk about this now. Later we'll talk. This is the constant you can key, primary key, foreign key, check constant key, and other. So if you are creating the partition table, then you need to provide your child table information. Then parameters, you can enable this as the default parameters for your table. And if you wanted to make a change, you can edit this. And the security. Finally, you can see the SQL. So what it is executing generated. Create table public.txt1, and this is the column I executed. This is the name and the primary key and the alter table owner. So this query is executed in the diagram. You can click, that will be created. The test1 is created. Now I can read my test1 table. Right here test underscore T1, and I'm able to read the data, but then there is no data to be empty. That's it. Empty table is displayed. So this is how we can create type, we can create view, we can create sequence, procedure, methodology, view, function, foreign, table, everything we can create using the PC admin. So this is why I said, so PC admin is a graphical tool where you can do all the operations. So like there is a maintenance command. We will see what is maintenance next class. So this is the option to refresh, count rows. This will count the row on the table, delete and drop. So this will delete your table and drop this. It will delete your table and the dependency. And the reset text will be import export. So if you want to load the data into the table, you can use import, or if you want to unload the data from the table, you can use export. And here you can maintain it to run the vacuum. And if you wanted to create the script of your table, you can use create script, which will create the script. You can copy the script and you can run it on another database to create the same thing. Let's say click on the create table, you can see it will generate a script for your table. You can say this is the script. This script you can copy it and run it on other database. And same way, you can, if you want to delete script, select script, insert script, update script. And thank you to use it to delete the data from your table. And the backup, to take the backup, you can also use this backup table. And the restore, if you have a backup already, you can also use the backup to restore it. Then if this is to view the data, this is same like this select start from table. If you want to see all the table, you can run this. This will execute the select start from table command. And the search object, so if you want to search any object, you can use the search. And this is the query tool, which is to open the separate window. For here, you can also run the command, type the command. Then the property command window shows you the property of your table. That's what we have created. Same if you want to change anything, you can change it. So this is how not only the table, you can do all the objects. Here you can create, you can delete, you can manage, you can alter, you can update, you can delete, you can truncate using the PG admin. So there is not only the PG admin, there is some other tools also. This is the dbms. This is also the open source tool. If you want, you can use this tool as well for managing. Same thing whatever you have discussed on the PG admin, that same features are available in PG admin with some advanced features. Like it will give you some, I think I have not installed. To install that, you can download the PG admin dbms. You can see here, this is the dbms executable file. I already downloaded and kept it. To install that, simply run the double click on it and press OK. It will say welcome screen. Next, there is a two version. One is the licensed one version, one is the community. This is the community one, you can see dbms community, and there is licensed version also that you need to pay, but you can use it. You can see dbms community. So simply click next. In order to not do anything, it will simply install it in your system. So which is like also PG admin. You can use it for managing your PostgreSQL instance. So there is another tool like I'll tell you this. So this is our option available here. Community, this is also open source. If you are interested, you can download. Not only these three tools, there are many tools available in the market. So whichever suits you, you can download and use it. There is no restriction or anything for using that. Any tool you can use. There are many tools. So I basically use PG admin and the dbms. So dbms is also very good when compared to PG admin. So here you can see I installed the dbms. To open this, I'll click my dbms, which will open. You can see this the dbms community is showing that it's just opening. So it is saying that community edition of it is not the professional or paid version. So if you want to paid version, that is also available with the more option. Okay. So community is very limited, but if you wanted to use the paid version, that will give you the more features. You can visit, to download it. You can use dbms website. So you can simply type here dbms. So it will take you to the dbms website from where you can download it. So this is the dbms website. From here you can download the tool. So dbms database tool. You can simply download. So dbms not only for the Postgres, it will also support for other databases like MySQL, Oracle, DB2, Teradata, all the databases almost. So all the databases will support. So it is still loading. So here you can see the dbms is loaded. So this is the first screen, and you can see it automatically detect your available database in your system. You can say I have a PostgreSQL system database. So this is the localhost 5432 MODT, and you can see this name. So here you can write select. So here is also one thing very important. This will help you to write the command. Here you can say I written only a PL, which is saying that select. you can use the select star from, and if you don't know from, it will give the from command also. From, then let's say that I don't have any table like this. If you have a table, then okay, let's say table set no table here. So you can write here select, it will say, see, it will say public schema. There is no other schema. So if you say that, let's say I have a demo underscore schema, it comes to demo underscore schema, it automatically comes. And dot, you can say this many tables I have inside the demo underscore schema. Here is the schema, demo underscore schema. You can see I have this many tables. If I say demo underscore schema and I don't know the name of the table, I just set that star, you can see this many tables I have. You can simply write the EMP. So, and if I want to execute, here is the command executor. You can run, so that will be executed and data will be displayed here. So this is very easy, very much usable tool. So we can also install and try it. So all the options you can do, whatever I discussed in PGI thing, same thing you can do it here. So it's a good thing. The good thing is that it will automatically prompt you the command if you don't know the exact command. Like demo underscore schema, you can see demo underscore schema available. I don't know the table name. If you just type the table, star, and if you don't know the exact name of the table, let's say order. So you can see which out of the start from this is the order. So you can simply execute. Okay, the data is executed. So this is how you can use the DB as this. So all the tasks, if you want to create a table, you can right click here and you can see create new table. So, and there is a SQL editor which is basically open another this window. And this is the connection. So if you want to create a new database connection, you can simply click here and they provide the PostgreSQL. As I said, it will call our Postgres also support the other database. So you can simply click on the PostgreSQL and click next. And here you need to provide your host name of PostgreSQL. So first name of PostgreSQL, which IP address of your Postgres server, and the database name, and the port number of your PostgreSQL, and the username and the password. Then simply first test the connection and then save it. That's it. It will create a server like here. So like this it is. So I have this many servers. So this is also daily for this one cloud machine connection. This is also navigate because this is the local host. This is local host again. So you can see I have a Postgres database. Schema, I have public and the table. The connection is possible. So this many tables I have. So this is how you can basically, use the DB answer to manage your PostgreSQL. Okay, I'm going to be showing the two tools, that is DB and the PostgreSQL, DB admin. So you can use any tool, not only this tool, there are many other tools. I'm saying that many other tools are available. You can use any tool, whichever suits your environment. Download it, use it. These all are the open source tools. Okay, there is no any condition or limitation on using this. You can use it. There is another tool called the OmniDB. You can also download this. This is also community version is available. Both the version is available, community and the paid. You can download the community and use it. Same thing like a DB user, it will also use the monitor window and the same functionality like this. And there may be some other mini features or some functions, but all the tasks you can do using this tool. So if you have interest on this, you can download and use it.
I will talk about the security module. So how to enable the security in PostgreSQL. So we will see database security requirements and the protection plan and the what are the security options are available in PostgreSQL. Then we will see host-based access control, how to enable the host-based access control in a PostgreSQL. Then we see authorized and then access method and the row level security, then the data encryption and the best practice of the security. So what is database security? Database are a core component of many computing systems. So because database is a very critical, because it stores actually your valuable data or some, like what you say, the data where you store, that is maybe some confidential data that cannot be shared with the others. So that is why data as a database are a core component in many computing system, and confidential data like is in healthcare or banking details are stored and shared using the database. So it is basically storing the actual data, and what is very critical to protect the stored information from the hackers. So that is very important because there are the hackers, they will hack your database or application to steal the data, because data is very valuable. And database security is a mechanism to protect the critical business data against threat. So in the PostgreSQL, we have two methods of authentication, that is two method of the security, that is authentication and authorization. The secure access is a two-step process. One is the authentication. That means ensure that user who he or she claim to be, the users who is, that's depend on your username. And the authorization, ensure that authenticated user has the access to only the data for the which the user has been granted to the appropriate privilege. So again, I said, if we have a user, if we have a given the access to the user to connect the database, that doesn't mean that that user can read the data from your database, because you are given only the connect privilege to the user. The user can only connect the database. To read the object, again you need to provide the grant select privilege to read that object, read the data. That is why first is the authentication, where you need to ensure that the proper username and the strong password is set for the user. And the second, authorization, that means you need to provide the privileges as required. It is not like that if the user is created and all the permissions you are given to that user. You need to restrict the user to read the data from your data. That is why if the user requires only that to read the one or two tables, you need to provide the access to only those two tables, not entire tables from the database. The levels of security in PostgreSQL, we can say three levels of security. That is the server and application level security, and the database level, and the object level. What is server level application? The server level application level security. So in a PostgreSQL, we have a tool called file called pg underscore hpa, which is basically used in the PostgreSQL to restrict the user to user who is connecting to your database. So the user cannot connect the database without whitelisting the system IP address on a PC PostgreSQL. You need to add the user client IP address, user who is connected to your database. The IP address of system must be whitelisted in the pghpa.conf file. Then only that user can connect your database from the remote machine. Otherwise, the user cannot access your database. So that is what we call it server and the application level security. So outside the server also you can configure, like if you have a firewall on your application, that is all not the database level, but outside the database we can set up the strong network, and you can set up the firewall on your server. So that is operating system again. When you talk of the database, the first security is the pg underscore hpa conf. You need to be set it very carefully. So we will see how to set up that for the particular users. And another is the database level security. So when we talk about database level, so there is a user and the password. That comes first, because that is cluster level. So user and password must be set proper. Like a user should be a proper, and password must be set to the strong. You need to set the strong password. and the connection privilege. So you need to provide only the required user, like you need to set the appropriate privilege for the user. Do not give the super user to all the users, because super user can read all super user can do anything on your server. Create a normal user and give a only required permission, like a connect privilege on like if you have a 10 databases, do not give all the connect privilege in all the databases. So which one user requires which database, only give that access. And the schema. So schema is basically used to store the object. So give the schema level privileges. So not entire database. You can restrict here also. Instead of giving the entire table permission, entire schema permission, you can simply say, if you have a multiple schema, you can also specify you can restrict the user to schema wise as well. That is what we say in using the CRUD statement. And the table level. So if you have a 10 or 100 tables in a schema, do not give all the table permission. If that user requires all the table, then only give. Again, while giving the access, you need to check what kind of permission he requires. Only the select or delete or the update or an insert statement. So depends on that user requirement, you need to provide that access on only for those objects, not for the entire your tables or entire objects inside the schema. So this is how you can secure your database. This is the another way to secure the database. Secure the data from the hackers. And the other option I told, that's the pghp.conf file. This is the one main file which will basically stop the unauthorized users, block the unauthorized users. So it is basically authentication is controlled via pg_hpa.conf file, where HPA stands for host-based access control. So host-based authentication. The pghpf.conf file is often located inside the data directory, but it can be specified inside the PostgreSQL.conf file. So by default, the pg_conf files are kept inside your data directory. The initdb is the responsible for creating this file. Whenever you initialize the cluster using initdb, the initdb will create this file inside your data directory. And when changing the authentication, you need to send a sign up signal, and this is done via several methods based on the PostgreSQL platform. So once you have added entry for a user inside the pghp.conf file, then you need to tell the PostgreSQL to reload the configuration or reuse the configuration, which will basically reload the changes to your memory. And the order of pg_hpa.conf file records a one entry is our record our entries is important. The session connection is compared with the pghpa.conf file records one by one until it is rejected or end of the configuration file is reached. That means it always read from the top to bottom. So it will check, let's say that you are the user and there is a one user is connecting from the remote machine, and you have given that entry in the pghp.conf file. It will read the PostgreSQL pghp.conf file from the top to bottom. So if you have entered then the last, it will check each entries, and when that entries matches, it will accept the connection. Otherwise, it will simply throw an error. So finally, it is important to check the PostgreSQL log file to determine whether there are error after configuration the reload. So after changing the parameter, you reload it. So if you wanted to confirm or verify it, whether that is valid or not, you can check the PostgreSQL log file to uh, verify that configuration is loaded or not. and pghp.conf file, which basically reads at the startup and change requires the reload. So it will always read whenever you start your database, and if you change any, if you made any changes inside the pghp.conf file, then you need to reload it. Then contain the set of records one per line. Here also you cannot add a multiple records in a one line. This is a one per line entry. Each record specify the connection type, database name, username, client IP, and the method of the authentication. So you need to provide the connection type, which is the host or the local or SSL, any method you are going to use, that method you need to provide. That is the connection type. Then the database. Database means which database you wanted to connect. So if you have a multiple database, then you can also use all option to all the option. Otherwise, you can use comma separately database name, or you can use a single database. And the next is the user. Which user you wanted to allow to connect that database. Let's say that database 1, you said db1 and the user 1. That means the user 1 can connect to that database. So if you have a multiple database, then you can see comma separated. That means the user 1 can connect to that multiple databases. Then another it comes that IP address. That is the client address. Where you need to specify that your client IP address, from where that user going to access your server. You need to provide your IP address of the client machine. Then authentication mode. So which mode? You need to allow that connection unconditionally, or you need to ask them to enter the password. So or if simply reject, you can reject. So there is an authentication method called trust, which is unconditionally accept the user request, and reject to reject the request, and MD5 it is basically a MD5 encrypted password, and the password it will simply blindly it will pass the password. Then GSI, SSPI, Cargos, Ident, Peer, Palm, LDAP, these are the different kind of authentication. Like if you are using the LDAP server, you can use the LDAP, or if you are using the Cargos server, you can use Cargos, or if you are using the Active Directory, you can use ident. The peer is to check the user operating system users. So there are, or if you are using the SSL connection, you can use SALT option. So there are other authentication methods also available that can be used in the authentication method. So here is the example of the pghp.conf file. As I said, which is first tell you to the type. What type? If you are using them, if you wanted to allow the user to connect the local machine, then this is the local. That means from the server you can connect. Then here is the IP address 4. So here is the host. This is the type host. That means the remote host. And the all means all the database. All means here is user, all means all the user, and the IP address. This is the local IP address. Using the local IP, all the user can connect all data, all the database. And this is for the IPv6. If you are using IPv6 address, then you need to add here. And this down, the last 3 is it is used for the replication. That we'll see in the replication part, but it is same like a upper part. But this basically mainly used for the setting up the replication and the backup. That we'll see how to set up this when the replication. But now we'll simply talk about this. This is basically a configuration where you need to add your client system IP address. Let's say that you are in the organization where you are a new developer or a new DBA join, and you need to provide the access to that user. So what will you do? You simply create the user on the server first, and you give the connect privilege on the database and the required object privileges. Then you give that user with this is your username and the password. And you install the PG client or a PSQL client on this laptop. Now he wants to access that database from his laptop. How do we access? He uses the PG pool, PG admin or a PSQL command line utility, or any other application. He may want to connect your server. To connect the server, you give him not only the user, you also give him the server. You also give a server IP address, port number, and the database name. Using this, the user can access your server. But if he has that user information also, he cannot access your server, because you need to whitelist that user information here in the pgsp.conf file. So if that user is accessing from the system which has IP 192.168.1.100, then here you need to add host and the database name, let's say that db1, and the user, let's say user1, and the IP address 192.168.1.100/32. That means from the only that IP, and the authentication method you can see password or MD5. Do not give a trust option for the normal user, because they can connect without the password as well. So once it is created, then simply reload the configuration, then the user can access the database from his laptop. So that is what authentication in PostgreSQL. That's pgsp.conf file. So, and PostgreSQL also, give you the self-explanatory message. So if you don't create that, if you forgot to add that IP address, or if you are facing some issue if users are facing some issue while connecting the database, basically PostgreSQL throw a self-explanatory messages. That means you can easily understand that what is the error and how to fix it. So here in that slide, you can see the first error, the pattern no pg_hp.conf entry for host, the user, demoed user, and the database demo db. See, this entry clearly tells you that there is no entry inside the pghp.conf file for the user, demo user, and the demo db database, and the host IP 192.168.1.25. It clearly tells that go and add this entry inside the pghp.conf file. Then it will allow you to access it. And second error is password authentication failed for the user, which is telling that you are entering the wrong password. And user demo underscore user does not exist. It is also clearly said that user is not created in your server, or you are entering the wrong user. And the database demo underscore db does not exist, means that you are entering the wrong database name, or the database does not exist on your server. So this is the very self-explanatory message displayed in the PostgreSQL. And it will verify the database name, username, client IP, and in pghp.conf file. And once that verified, then if it is not exist, then create the configuration for create the entries in pghp.conf file and reload the cluster. And again check the log file to verify that whether it is taken or not. So let me show you the quick demo for pghp.conf file, because user creation we have already seen. So we have already seen how to create the users and all. So now what I'll do, so I have a cluster which is running PostgreSQL. So here I'll connect to PSQL-P. My database running on 5434. Okay. Sorry, I'm in the root user. I'll switch to Postgres user. So PSQL-P 5434. So this is the server. Now you can see -a. I can connect. There is a 3 databases, and the user, I have a 2 user, which is one is the replication user. Now I have a Postgres user. So here I'll show you that. See, this is my AWS cloud machine. I'll show you that as well. So this is my AWS cloud machine. Okay, this is my public IP. So if I want to connect this server from a local machine, so I'll open the command prompt here, and what I'll do is I'll simply I'll use my PostgreSQL binary path, that is program files PostgreSQL 13 and the bin. Here I have a Psql and I'll say hyphen h, which is my IP, which is my remote server IP. Okay, and hyphen p 5434, and I will use user, that is Postgres, and hyphen d database. I am going to connect the Postgres. Now if I enter here, I cannot access. So this is the different error. I'll tell you why, because I need to add access inside my AWS cloud. This is not the database security, it's the AWS security. I'll show you how to enable this. So here you can see inbound and outboard, because this is not related to database. I'll tell you, I forget to add first. So let me add it now. Here is the networking. There is an inbound outbound option, security. You can see inbound is outbound is all on. So inbound I need to add here. I want to enable that port number, which is 5432. So inbound, edit the inbound roles and add roles. TCP IP port number is 5434, and I'll allow it from all the IP. So this is actually a AWS setting, it's not a database setting. I'll save the roles. So otherwise it will throw a different error. You can see this say connect to service is a different error. So now you can see it is added. Now it should allow me to access. I'll connect. Yeah, it will depends on the error you can identify. See, now I can see it is throwing that same error which I showed in the error, which is saying PSQL error pattern, no pghp.conf entry for the host. This is my laptop IP address. And saying the user PostgreSQL data, Postgres is SSL off. That means there is no entry in the pghp.conf file for this IP address and this user. That's why it is not allowing to connect my database. So if you wanted to connect it now, you need to add an entry inside pghp.conf file my server. So I'll connect my server. This is the putty access, and I'll exit here and I'll open my configuration file that is inside my data directory. My data directory is the standby, and here you can see I have file which is pg_hp.conf file. See, where is my pghp.conf file? pg_hpa conf file. So this is the configuration file basically created when I initialize the cluster. So you can see the pg_hpa conf file. So I'll open this configuration file. You can see this is the file. This is the configuration I have shown you in this. This is the default configuration is available. Now if you want to allow that instance, so I'll add here. You can add it anywhere. You can add it end, you can add it in the middle, or you can add it in the beginning of the file as well. So the host is used for remote system, and all, instead of all database, which database I wanted to access, the Postgres. I'm using the which user I'm connecting, the same Postgres. If you have a different user, you need to add that user database name. And from which machine I'm trying to access, from this machine /32. This is the IP. This is the IP of my system. You can see 43.241.120.21. So this is the IP, and here I'll say trust. So that's, sorry, I'll not use trust. If you trust, it will unconditionally accept, and I'll say MD5. It will ask me to enter the password. So here I'll save. Once it is saved, then you need to reload the cluster. Reloading, we have a utility function called pgctl. You can use that. Otherwise, another function which is pg underscore reload. So here I'll connect it, select pg underscore reload the function. It will simply reload pg underscore reload underscore conf. It will reload the configuration. You can see it is through. Now, if I connect my laptop, the local machine, and if I run same command, and if I enter here, it will connect my, it is asking me enter the password. You can see, I'll enter, then I connected to my cluster. If you see DU, you can see I have that many 2 users. So if I create here one more database, create database demo underscore db, I connected here. And here I exit from the database, and when I connect again, I'll change the database. You can see if I Postgres try to connect the another database, which is the demo underscore db, newly created database, but you cannot access the database. Why? Because for PostgreSQL database and this IP, that is only we have enabled the one database, that is pghp.conf. You can see I enabled only the one database, that is Postgres. The Postgres user can connect only the Postgres database from this machine. So the user cannot use other database. So if you wanted to allow, you need to add another int. Or you can simply say here in the configuration file, you can simply say a comma separated like demo underscore db, and you can save it. I don't know which answer, so that we check it goes twice. Reload conf, and if you want to check, you can check the log file. So whether it is taken or not, the log tells you that that is a configuration is right or wrong. If it is restored sign for the PGHP or the user Postgres database demo SSL. Okay, so you can see that configuration is reloaded, and I'll exit here. And now if I connect to my local machine, and if I try to connect the demo DB database, then it should accept. So you can check in the password, and it says here it is connected. So this user, the Postgres user, can only use this machine. This user cannot use another system. If he try to connect the database from the other machine, then it will again throw the error. Because I given only the one IP. Here you can see this is the IP. So here in the configuration file, I'll show you in the configuration file, I given only the one IP address, which will only allow that IP address, which will allow the user to connect from only from this machine. The user connect to try to connect from the 22 machine, then he cannot connect. So that is what security in PostgreSQL. You need to add the client IP address in pghp.conf file. And if you wanted to allow that user, like let's say if you wanted to allow this entire this Postgres user from all the IP address from the 120 series, we can simply say here to allow all the 254 subnet mask or IP address, we can simply remove this 0/0, which will accept all the IP from the 128 series. That means 1 to 254. That means 2 to 54 IP machines are allowed for this user. This user can connect from this IP series. Or if you wanted to allow all the IP address, we simply can see 0.0.0/0. This means this user can connect from any system. This user can connect the Postgres database and DemoDB database from any system in the network. There is no restriction for the user. He can use any system to access the database. So this is how you can configure it. But do not use the 0000 For all the user, you can specify for the single user. Do not specify all user like a host and all database. Let's say that if you are wanted all the database, that means the all the database can be accessible from all the user. So all the user can read, connect all the databases. If we say 0.0.0.0/0, that means any user can connect the any database using the any system. There is no security in the database. Any user can connect. And if you again say trust, the user does not require the user password itself. They can connect without the password also. So if you wanted to show you, I'll simply show you in my existing one. I'll simply change the MD5 to trust, and I'll say show you the trust, and I'll save this configuration WQ, and here I'll connect my cluster and reload the configuration again. So it is reloaded. Now I'll connect to my client machine and I'll exit here and I'll connect again. You can see without password, without asking the password, it's connected. That is what trust. Do not give a trust access to any user, because the user can access the database without the password. That's why I said it unconditionally accepts the user request. This is what pghp.conf in PostgreSQL to secure your database. And as I said, there is a other authentication method is also available. That is, as I said, trust is unconditional accept, the reject it is also simply reject the user connection, and the MD5 which is encrypted password, and the password which is password option which is the plain password, and the GSI, APS, address, identity, these are the different kind of the authentication method. You can use the MD5, and there is another secure MD5 advanced option also available. You can use that also. That is SCRAM 255. You can use that authentication method also, which will also encrypt your password in a secure way. Another is the row level security. So role-level security is a feature where you can restrict the user to read only their data instead of entire table records, and which will be completely managed by or controlled by the DBA rather than uh, application owner, and uh, which is basically used for restricting the user to view the data on the table. And as I said, grant and revoke can be used to the object level. That is, you can grant or revoke the privileges from the user on the table. And by default, all the rows of the table are visible for the user if you provide the select statement. And if you create the row level security on the table, then all the query you execute on the table that must be pushed through the security policies. If you don't create the security policies, then user cannot see the record. Security policies are controlled by the DBA rather than the application owner. And security policies, the row level security policy offers a strong security as it is enforced by the database. So here is the example. I have created the employee table with the multiple columns, and I have enabled the row level security on the table. So before exampling this, I'll simply show you directly I'll show you the demo, because that will clear you all the doubts. So let me connect to my instance EC2 hyphen user password. So what it does basically, this um, row level security. So I'll connect here my PostgreSQL instance using the my PSQL. Okay, so I'll switch to my Postgres user. Let's forward. Okay. Here I have a PSQL-P 5434. So you can see I connected and I'll create one table called create table EMP, and I'll say EMP number, which is INT and INT, and I'll also create primary number key on this primary key, and I'll say name comma varchar, that is a username, and I'll say salary INT. Okay, so this table is created. Now I'll insert the record, insert into the EMP values. I'll say users ID 7777 and the username is I'll say okay, Kalyan, and Kalyan salary. So remove this, and this is the Kalyan salary. So, and another entry I'll insert here is the different ID, that is 888. The user employee code is 888, and the name is Jack. So I'll add this salary also. I'll remove this and remove one column, and I'll say 88, and this is another user salary. And also I'll add another user, which is Mark, and I'll change the ID, so which is I'll make it 999. So let's say I have 3 users. They have the different username and the, let's say 77. So now if I write select star from EMP, you can see I can read all the data because I am the super user. Super user can read all the data from the table. Now I'll create the 3 users. Create user. The first user is Kalyan, and I'll say login password. Password I'll keep it simple for testing purpose. When you are creating the real production or a real environment, you need to give a strong password for the user. So, and the another user I'll create, which is Jack. I'll create all 3 users here: Kalyan, Jack, and another is a Mark. Now I'll connect the database Postgres using Kalyan. So you can see Kalyan is connected. Now if Kalyan writes the select star from on my EMP table, he cannot read the data because he is not the owner of the table. He does not have access to read it. See, there is no permission. If another user connect, like say Jack, even Jack also cannot read the data because he is also, there is no permission for this user as well. So to give the access, you can simply give a grant select privilege. So he can simply read the data. So I'll simply here give grant select on EMP to Kalyan and Jack and Mark. Sorry, I should work on separately. So you can see the grant. Now the user can read the data. So if I connect to Postgres database is the Kalyan, and if I run select star from, then he can read the data. You can see he can read all the data, not only the Kalyan record. He can also read Jack data and the Mark data. So this is what the security. This is where there is no security. So this user, Kalyan user, can read Jack data, Jack salary also you can see, and the Mark salary also you can see. To restrict that, you need to enable the security. That is what row level security. So if I connect the Postgres database using the Mark, then Mark can also read the others information. This is the default behavior of all the databases. To restrict the user, you need to create the row level security. So I'll see PostgreSQL and first I'll connect to PostgreSQL user and I'll use alter table. The table name is EMP and enable row level security. That's it, I'll enable it. Now if a user connects, let's say that connected Postgres database using the Kalyan user. Now if we say select star from, they cannot read any data because there is security is enabled. Once the security is enabled, that query has to go through the security policies. The policy you need to create. As of now, I have not created the policy. That is why it is throwing the 0 records because there is no policy. Policy, which is basically you write that what data that user need to read based on the username. Because I have a username in the table, I will check the username with the table record and display the data. So not only the Kalyan, the other user also. If you try to connect the other user, let's say Mark, and even Mark also cannot read the data, the empty. So why? Because there is no policy on the table. Only I created the row level security. I enabled the security feature, but there is no policy. So to create the policy, again I'll switch back to my Postgres user and I'll create the policy. Create policy and the policy name, that is EMP underscore policy, and on my table, that is which table? EMP table, and I'll say using. So here in this script I'll show you that security policy using the column name and your name. The what is column name here in my case? That is the name. The name equal to current underscore user. So whoever log into user, they can only see their data. So that's it. Before that I'll show current user. So current underscore user. So let me check this. Select what they will come. You can see it is showing the Postgres user because I connected with the Postgres user. So now security policy is created on my table. And if I connect the user like a Postgres database using the mark, then if I write select star from EMP, then you can see mark can only read their mark data. If I connect the Postgres database using the Kalyan can only read the Kalyan data. He cannot read other user data. And if I connect using the Jack user, if Jack user connected and if he is executed select star from EPI, he can only read the Jack data. So this is how we can restrict the user by reading others data. So if you want to restrict the user, then you can use the row level security. So then another security is that data encryption. The same way I told you, like is shown you in this example. So there is a table called, let's say that now if you don't want to, if you don't want to restrict the user wise, you just wanted to encrypt the data, the salary part, which cannot be read without the key. That is what encryption. So here is the feature called data encryption. So encrypting everything does not make the data secure, and resources are consumed when you are querying encrypted data. And Breachy Crypto provides a mechanism for everything encrypting the selected column. So it will only encrypt the selected columns. You can only encrypt your salary part, which cannot be read from the normal user. And PGCrypto supports one-way and two-way data encryption. And install the PGCrypto using the create extension command. Again, this is the additional function. You need to enable it on a PostgreSQL database by creating the create extension PGCrypto. So once that okay, so that is what creating this crypto. So once that is created, crypto is created, you can encrypt the column data using the function. There is a many function, so I'm not going to show you that now. So but we can discuss that same thing in the extension part. So but you can encrypt the data in PostgreSQL using the PGCrypto function. That is the function. So these are the security methods are available in PostgreSQL. And best practice of the database server is always keep your system patched to the latest version. Do not use the old version when our Postgres release the new patches, apply the patches. Before applying that, read the release note. First, before applying on and release the note, and check the what are the new features they have added and what are the features they have changed, and update the patches. Keep your database up to date. And do not put the postmaster port on the internet. And that is again the postmaster by default database port is 5432. Do not give an internet connection on your PostgreSQL server. Remove the internet connection, or if you are providing internet connection, then do not use the default port number, which is 5432 for your PostgreSQL server. And isolate the database port from the other network traffic. So if you are using, then you can also use the port mapping method to port the use the network mapping method to use other port number, which will basically translate to other port. And do not rely solely on your front-end application to prevent the unauthorized access to your database. And never use the trust authentication in a pg_hpa.conf file. As I said, do not use the trust authentication method in the pg_hpa.conf file. That will definitely harm your database because the user can connect the database without the password as well. And provide each user with their own login and allow the user to minimize the access to do their job and user load and the classes of the privileges. Use the proper user's role and the classes for the user, and view the role and the view security barriers, and use the row level security. So the views are basically a complex query. So if you don't want to share the entire table data or to with the other user, you can simply create a view and share that view name with the other user so that they cannot read all the data from the table. So you can use the row level security as well for restricting the data from the user or hiding the data from the user. And only allow the database super user to log in from the server machine itself with the local or the localhost connection. So remove all the other user privileges or connection from pghp.conf file where they basically all the user can connect the database from the server. So you can simply remove this by commenting on that all parameters. And reserve the use of the super user account for task or the role where it's absolutely required. So only use the super user account whenever it is required. Do not use the super user account for the normal activities. Only for the DBA activities use it. Do not use it for any application activities. And restrict the access to the configuration file. And by default, only the Postgres user can read this data or read the configuration file or the root user. So restrict this user from the other users. And this allow the host system login by the database super user load. So that is why this allow that super user roles also from the local machine host system. That means
If you are using the super user to connect from the remote host, then that is disabled. Only super user only connect from the your server, not from the client machine. So disallow that if you are allowing the super user from the other host or a remote host, and simply disallow that. So this is all of the best practice of the securities. And these are the options you can use. You can use the data encrypt method. You can use low level security. You can use PG underscore HP and TGSPI configuration. Without that, you cannot access the database. You have to enable, and the row level security and the data encryption is the additional option that you can enable in PostgreSQL to secure the data. And always remember that whenever you create the user, give a strong password and only use the specific IP address in the php.conf file to allow that user. Do not give the all the IP to allow the user from the all the IP. Do not allow the user from all the IP. Only allow that user from the specific IP. That means it's laptop, yeah, system, whatever that. Only allow this IP. And do not allow to create all option for the database and user. Only specify that user and the database name which the user wanted to access, and do not use the test option in the pghp.conf file for any user. So this is all about the security in PostgreSQL.
Performance tuning. So basically, when we talk about performance, the tuning part. So it is not only the database. It's not only about your SQL queries or the database parameters. There are many other, like you can say that when you say one server, if it is a dedicated or there was shared server. So there are many things like a memory, so which is we call RAM, and the storage, which is the hard drive, and operating system, and the networking. If your network is also slow, then the your PostgreSQL database parameters and the application tuning. So application means that your application code. These are the things you need to look. So when you face a performance issue, the performance tuning is basically one of the, it is a basically a group of activities to optimize the database, to correct the poorly written the SQL. That is what the first objective is, so identifying the poorly written queries or SQL statements. And the session management, as I told you, if that users are keep on very like for every transaction, if they're using the new sessions or new connections, then that will be a big overhead for the connection pooler or a postmaster, because postmaster is the one who receiving the connection from the client. That is why you can reduce that by using the connection pooling tool. Yeah, all the databases that you install on a you so whenever you install the PostgreSQL, the database is installed with the pre-configured parameters that is are very less and the very minimal. Why? Because it is minimal, because some of the operating system doesn't support for high configuration, so like a Windows. So that is why by default it is very minimal configuration is set. So that is not proper setting for your database. So you need to change your parameter. That is what misconfigured database parameter. Then the operating system IO, that is all about your storage. So then if you do not maintain your database, like what is maintenance? So we need to run a vacuum analyze on our database to update the to remove the data pools and to update the statistic, and to prevent the database from the transaction wraparound failover. So these are the things that DBA should maintain. Before jumping to, so we have seen that SQL part. Today we'll be talking about only the system parts and the parameters. The first thing we need to talk about the operating system. So once you install the operating system, basically system admins, they'll install the operating system and they'll hand over to you to install the database. So before that, they will basically tune all the operating system parameters like a memory and the CPU and the disk. So they will provide you that based on your requirement, like size and all, but sometimes there is a speed. So in the operating system, when we talk about the memory, so we need to increase the memory demanded whenever that you see that when you monitor your server or a database, you can see the spike on the RAM, like how much memory is used to in the peak hours or in the normal transaction. So based on that, sometime you may increase the RAM, or you need to check that which process is checked using the maximum percent of the RAM. You need to try to reduce that, or you may the final option is to increasing the system physical memory. So that is why you need to check the uses of the memory. The solution is to reduce the memory or increase the system RAM. So to monitor this, there are many tools are available, like a system operating system, which is not completely database related. So it is all about the system related. So if you have a system team, they will provide you all the details. So then next part is the CPU. The CPU is the core of the system, which is the RAM. It's not RAM, sorry. We call it processor. So the CPU may be the bottleneck when you load or a process is, process weight is high. So whenever the process CPU is 100% utilized, so the sessions will wait for the resources. So that is why you need to check that CPU utilization in the database as well. So like I said, there are many tools are available. You can use the tools to monitoring your system. So the solution is to reduce the uses of the disk. So how do you reduce? Like I said, if the one query is using the 50% of your one CPU, let's say that if you have only the core of CPU. So if your one query is taking the 50% of CPU, utilizing the 50% of CPU, if that query completes within a millisecond, that's okay. So you don't need to worry about that, because the 50% is used within a millisecond, that task is completed, and again that's resources is free. But if that same session is running for the 10 minutes, then for the 10 minutes the resources will be uh, used, right? So that is what you need to try to reduce the execution time of the query. That is why we can reduce the uses of the CPU and the memory. So solution is to reducing the CPU. You need to identify that queries, and you need to try to reduce the system resources uses like a CPU and the RAM. And the third one is the disk IO. So what is disk IO? So as I told, whenever you insert or update or read a data, the basically data is whenever you read, the data is read from your hard drive. If the data is available on the memory, then it's read from the buffer. But if it is not available on the buffer, then it will directly read from your storage. Whenever you insert, whenever you modify or you delete, so data is deleted from your storage, not from the memory, because the data is mainly stored in the storage. That is why whenever you choose by the server, you need to focus on not only for the size of your storage. So you need to check that speed of your disk, that is we called IOP. So you need to check the speed of your storage. So in the operating system, there are many utility functions which will display the uses of your VM stat, SAR, or IO stat, which basically display you the uses of your systems, RAM, and the CPUs. So using this utility function also, we can monitor the you can check the system utilization. Or if we have any tools, like there are many open source tools are available for monitoring their CPU, not the database. It's all completely about your system. So you can make use of any one of the tool, and you can monitor the your system. Or if you have a system team, system admin teams, they will provide you the all the details. So these are the main three things you need to check when you actually have a problem in the performance. Another thing is that configuring the hardware. So choosing the hardware is also the one of the major part of for the performance. Like I said, So focus on the disk space and RAM over the CPU speed. So if you planning to buy a system for your database, then first you need to focus on the disk speed and the RAM, not the CPU. CPU, if the CPU is also slow, then that's okay. But main thing is that you need to put a good IO on the storage and the RAM on the server. So because like other RDBMS, the Postgres is also the IO intensive. Whenever you configure your database, so put the your PG wall directly. That is what we call transaction logging. Put that logs directory in a separate directory, not the directory, separate storage. Because when you choose a separate storage, that storage will have separate IO. That's why choose a separate storage. Do not create a multiple directories within a storage and separate it, because use the separate storage. If you have a multiple storage, then just take the one null of that storage and create a directory, and create the PG wall directory or a transaction log. Put the transaction log inside that separate directory. And if you have a very tables and indices, so which table may be heavily accessed, then separate that, create a table space on a different storage, and spread that tables and the index and across the storage. So setting the disk to match the speed requirements, like not just size requirements. As I told you, do not look for the only the size of your storage. You need to buy the storage based on the speed of the your storage. So IOP is the IOP is a very important thing that you need to check. What is the IOP speed when you purchase the hardware? And the write 0 plus 1 is the optimal for the speed and the latency. So write 0.1 means write 10, so you can choose the write 10. So sometime the system team will ask you for what write level is required for your database directory. So we can tell them that write 10. So because that is the optimal speed for your database, then write caches must be a persistent, like now this is okay because all the storage else comes with the battery backup. So why it is battery backup? Otherwise, if the files goes down, so power goes off, so your files will get corrupted. So but now all the storage comes with the battery backup, so you don't need to worry about that. But only thing is that you need to worry the storage IO part and the write level. So, and the file system is like, file system also makes a difference when when you create the file system for your direct database directory. The journaling file system is not required for the transaction log. You can simply put that, RAM based storage also for your transaction log, but journalism is not required for the transaction log. So how you can use the same like a database data directory storage. So on the same type of storage, you can use it for the transaction logging. So if you do not have a RAM based one, then multiple options are available for the Linux, like ext2, ext3, ext4, sfx. These are the file system which is available in the Linux. You can use any one of this for your database. And but do not use the remote files, which is NFS. Do not use that network file system or a remote file system for your database directory. That is also slow down your database. Keep in mind that never use that NFS file system for your database directory, and use that ext4 or sfx, or sometime if it's old, then ext2 or ext3, based on the version you can use this. Then finally it comes to the server parameters. So we know that the database PostgreSQL contains one configuration file, that is a PostgreSQL.conf file. So all the parameters are created inside the PostgreSQL.conf file, and we also know that whenever you modify the parameter, the database behavior gets changed. So because the default PostgreSQL.conf file server parameter configurer configured for the wide capabilities. So that is not the final, tuned parameters. Server parameter must be tuned for the optimal value for the better performance. So parameter can be evaluated using the different methods and can be set permanently in the PostgreSQL.conf file. So we know that how to set the parameters because we have seen that in a parameter configuration module. We can use the alter system, or you can directly open the configuration file and you can change the value. We also know that some parameters requires the restart, some parameters simply take effect by reloading the configuration. So how do you basically configure the parameter? So you need some information to set the parameter value. That is what database size, large table size, type of the frequency of query. So then available RAM, number of concurrency connection, number of CPU. So based on this, we'll configure the parameters. So what are the we have seen many parameters in a PostgreSQL. There are nearly 370 parameters are available, but which will not all the parameters will be affected to your performance. There are few parameters which affect the performance, like max underscore connection. So why this is important? Because so this will decide that how many concurrent connections are allowed in the database. So by default, it is 100. That means the 100 user can connect to your database at a time. But if your application requires more, then you may need to increase this. Or you can decrease also if your database is using very less connection. Or again, if your system resources is very small, like I said, if you have a 16 GB of RAM and 4 CPU processors, but your application need thousands of connections, so thousands of concurrency connections. Yes, you can set that. You can configure the parameter. That's not an issue. But what happens if that user connects, the 10,000 users connect once at a database? Your database definitely hangs up because you do not have that much of resources to handle the 1,000 connections. So that is why we need to use the connection pooling. That is what we use the PG pool or a PG bouncer. These tools will help you to manage the connection in the database. You can configure the page pool if you have in such a situation, because user connections as a associated with the user backend process, because each user connections are a separate process in the database. So each processor also each user sessions or a Postgres process are assigned with some resources. So that's what, if you have a very small set of resource, then you cannot manage the large number of concurrent connection. So only that connection pooling can decrease the overhead of postmaster by reusing the existing connections. The good thing is that the connection pooling is that it will reuse instead of creating the another sessions. It will use the previous session. So that is the one benefit, because there it will reduce the load on your load from the postmaster. Then the shared underscore buffer, so which is a memory parameter. So we know that it in a PostgreSQL, once you start that, the shared area is initialized. Inside the shared area, there is a memory called shared buffer and the wall buffer. So whatever the transaction you do on database, everything will be recorded on the shared buffer. So by default, the shared buffer, this is the area basically buffered and used for the database server. This is the buffer area is used by the database server. So in a database, each buffer is a 8 KB by default. This you cannot change. So, but if you are using the source code, then you can change, but do not change this because this is the default settings. Minimal value you can set up to 16 and at least 2 times of your max connection. So not exactly like that. You can set like 25% of your system available RAM. So if you have a 100 gig of RAM on your system, then you can set the 25 GB for your shared buffer. That is what you can set. This is a rule thumb of configuring the shared buffer. But sometimes you can increase, but do not set the large, like 50% or 60% of your available RAM. That is also sometimes slow down your server. But initially you can start with the 25% of your available system. That is the good number that you can set for your shared underscore buffer. As per my experience, I have used it to max 35% of system RAM. The sum of depending on the server or depending on my project. So I have said, but initially, whenever I start a new project, I'll start with the 25% of available RAM. because these parameters are required the server restart. You cannot change every time. So first change it, then once you feel that if it's required more, then you can increase and restart the server. Then the work underscore memory. So the work underscore memory is amount of memory is assigned to the all the user sessions. So if the whenever the user connect to database, so that user sessions are assigned with the work underscore memory. So that is depends on that how much GB of RAM you have used on your system. So let's say that if you are using, like I said, 8 GB of RAM, and you are, you are allowing the 1,000 user connection. Then if you divided 1,000 into 8 GB, then very less amount, and depends on what kind of the queries you run on a database. Like if you have complex query, which with the join of 8 or 10 12 tables, or if you're using the order sorting method on a query, that it all depends on like your query. So this parameter, not only the you can also set by the session level or a user level, database level, so or the cluster level. So here you can do one thing. So if it's any queries which requires the more work memory, then before executing the query from the application, you can set the parameter for that session. Only it will be used for only for that particular session. So that you can set the work underscore mem equal to that value. Pass this value, then execute that your complex query. If that query is using the hashing and sorting, so that will take that query will be completed run faster in the database. And you don't run the complex query every time. So maybe very few times you run the complex query, and other time your application may run very small queries, so which requires a very small set of work memory. So we can set the cluster level small level, like you can start with the 1 MB or 2 MB, or if you have a use memory, you can set 10 MB, so our at 4 5 6 MB. So it depends on your requirement. You can say there is no rule thumb of configuring that work underscore mem. So that's all depends on that what query you use on your database. But as I said, you can start with 10 or 8 MB. So then maintenance underscore work memory. So it is like this memory is completely used for the vacuuming, creating index, alter tabling, and adding the foreign tables, foreign key on table. So that depends on that how frequently you add an index, how frequently you alter a table, how frequently you modify the structure of your database. So depend on that, you need to set this maintenance and work memory. And the vacuum is used. So there is other parameter for setting up the vacuum. You can also set the separate memory for the vacuum. So these are the memory. So initially you can go with 4 GB. You can set. There is no any calculation for setting this parameter. These all are depending on your requirement. So how many tables you have, how frequently you update and delete the data on the table. So depending on that, the vacuum will run in the background. So for vacuum purpose, the maintenance work underscore mem will be used. So depending on that, you need to set the value. So but initially you can start with the 4 GB or a little more if you have more RAM. So work underscore is auto vacuum work mem. So that's why I said by default this is disabled. That means the vacuum will use the maintenance workman. But if you wanted to set that separate memory for this, you can set it. Otherwise, you can decrease the maintenance work memory, and you can add this value in the work underscore mem. So otherwise, you can use the one parameter value for all the process like maintenance work memory. The another memory parameter is the effective cache size. This size of the memory is available for the disk caching, that is available for the single query. So that is not exactly that this much memory is used by the single query. This is the actually estimated value which is available for the single query. Your query may use that much of memory for catching the data. The higher value favor the index scan. So if the effective underscore cache size is higher, then which will basically choose the index on your database if you have an index on the table, which will basically speed up the reading. Rule thumb of configuring this parameter is half of the system RAM, or you can use the 75%. So it's depend on, like if you are using the 25% for your shared buffer, then remaining 75% you can assign to the effective cache size. If you are using 40% for your shared buffer, then remaining 60% you can add to your effective cache size. This is depends, because all the operating systems, all the database like the PostgreSQL also uses the two-way caching, which is operating system caching as well as database caching. So all the RDBMS will use this operating system and database caching like Postgres. So then temp underscore file underscore limit. This is again depends on your application. So if your application, when the temp underscore file is used, so whenever that your query exceeds the work underscore memory value, that is used for the sharding and washing. But if you select the more than that data, then if the data doesn't sit on that memory, then it will use the disk space to store that data, and once that process is complete, it will delete that file from the storage. That is the automated process. So that's, you need to check that what query you run and which query is generating the more temporary file. That all thing you can by identify by enabling the parameters in the configuration file. That is what logging parameter. In the logging that I have shown, the stem file logging, there are many parameters. You can enable that. So by default, default is set to -1. That means there is no limit. But if you wanted to set, like if you set to 100 MB, the temp file limit is 100 MB. Then if you run any complex query, if that query generates the more than 100 MB size of data, then that will be killed in the background. That process will not complete because the limit is 100 MB only. So be careful while setting this parameter. You can use the default one -1, because I never change this parameter because sometime the application may select your application may need more data. The user may require the more data. So if you set the value for this, then that would may impact your application. Then wall underscore level. So we have seen this wall underscore basically determines how much information is returned to the wall file. So which accept the four values like minimal, archiving, replica, and the logical. So we know that why these four are like based on your requirement. So if you do not have a standby concept, then do not use the replica. Simply use that archiving, like it will be used for startup recovery and point in time recovery. So based on your requirement, set this parameter. If you have a replica, if you have a concept of master and slave, then set to replica. Otherwise, do not use that set. So that is what depends on your requirement. Set this value. So because if you unnecessarily, if you choose the replica, so it will basically what it does, it will basically add the information in the log file which is required by the standby. If you're not using the standby, then why you want to set to replica? So that is why I said, so it will also speed up the process. So based on your requirement, you can add this. So yes, if you have a standby concept, then you have to set to replica. But if you don't have, then don't set to replica, use the archiving. Or you can also use the minimal. So if you do not have a recovery concept. Then wall underscore buffer. So this is again buffer area. We know that in the shared memory area, there are two buffers, which is the shared buffer and the wall buffer. So shared buffer area is to all the transaction in the same way wall buffer. So all the insert or update or delete. So what are the changes you make on database, that will be recorded in the two areas, that is a wall shared buffer and the wall buffer. So we know that what happens when you commit the transaction. In the shared buffer, the transaction is simply marked as a committed, but in the wall buffer area, that transaction is immediately synced to your storage. That will ensure the data durability in a PostgreSQL. This is basically by default set to 1, that means auto tuned. That means 3% of your available shared buffer, not the system memory, 3% of your shared buffer. That means auto tuned. That much memory is assigned to your wall buffer. The best practice of setting this value is that you can, if your wall size is 16 MB, then you can use the 64 MB, or sometime you can use the 32 MB also. The best practice that you can set to 64 MB. No, there is no problem. But if you have a large RAM, then use the default one, no issue. Then all parameters like a check pointer. So we know the check pointer will run in the every 5 minutes, or whenever that wall max size or min size is reached. So the check pointer will enforce in the background, and a max wall size, and by default it's a 1 GB. So sometime you may need to increase that checkpoint time also, which is 5 to 5 minutes. So if you have a heavy write sensitive database, then you may do set to 10 or 15 minutes, and increase that wall size. So max wall size and the min wall size. The max wall size is by default 1 GB, and the min wall size is 80 MB. You can simply set to max wall size up to 4 GB, and min wall size to up to you can set to 1 or 2 GB. So based on the requirement, but before setting this parameter, make sure that you have a storage space on your PG wall directory. Wherever you have mounted that directory, make sure that there is a space. If you do not have a space, then do not increase this. And wall parameter, another thing is the fsync. So this is by default enabled, and do not turn this off, because this ensures that all the all buffers are returned to the wall logs at the each commit. If you turn it off, it will corrupt your data. So do not turn this off, and turning this will improve the database performance. So but it will definitely corrupt your data. So in some time, if you do not, the data is not the important, only the performance, then you can disable this fsync. And the parallel queries, so which is also the very important thing, because this is by default enabled, so you don't need to do anything. So on the latest version, the 9.6, not 9.6, the 10 Postgres version 10 onwards, the parallel queries, the parallel sequence, parallel mode is enabled. So parallel sequencer scan allows the multiple workers to perform the sequencer scan. So as like its name, so it says the parallel workers. Instead of the one worker, it will start the multiple workers to complete the one job. That is what it speed of your process. The sequential scan is basically for the table scan. The same way parallel bit heap map heap scan, which is basically for reading from the index. So what happens if you do not have parallel? It will basically read, the one worker will read the indexes scan. But if you have a parallel, then it will again speed up the index scan. And there is an index scan, parallel join methods, parallel aggregate method. See, these are used for the some specific reason, like for nested loop, hash join, merge join. For the parallel joins will be used to, and if you have any aggregate functions are used in your query, then parallel aggregate function will be used to. So based on that, it will, and you can also parallelize your DDL statements, like a create table, select, then create indices, create metallized view. So these are the statements, like if you are creating the tables from some data, because whenever you create a table from the data, that will take some time to capture the data and insert into your table. So that we can parallelize it, and you can speed up that process as well. And creating the index is also the complicated things, like not complicated, which is the time consuming, depending on your table size. If a table size is too big, then your indexes will take a long time to create. So that is why you can also use the parallel DDL option to create the indices. Same way you can use the create uh, metallized view. So metallized view is also like a which is a query. So the group of the SQL, but that is not the logical group, which is basically data is copied and created in the storage. So it is like a snapshot of your query result. So that's why this is also speed up whenever you use the parallel option. So these are the options you can use it in a PostgreSQL. And here is the one slide that's non-derivable settings. So this is not recommended such thing. Do not do this. I'm simply showing that non-derivable setting means if you do this, your database will definitely corrupt. So that is like, as I told you, you can put your entire data directory on the RAM disk, which is not recommended one. I'm saying do not place your data directory on the RAM based disk. Then do not turn off the fsync. If you turn off, you'll get a good performance, but your data gets corrupt. Then turn off the full page writes, and this will also improve the performance, but do not do this on a production server. And increasing the max wall size and the checkpoint time, and do not increase it like a very big number. So as I told you, set to max 4 or 8 GB, but do not set to like kind of checkpoint time also do not set to 1 hour 2 hour. So like you can increase 5 or 10 minutes, but do not set change to the hours or more than that. Then turning off the synchronized commit. So this will also improve the performance, but do not turn this off. So these are the non-durable settings. Do not change this on a production server, because this will slowly corrupt your database. Then finally, database benchmarking. So what is benchmarking? Now you know that how to set the parameters. You have set the all the minimal you have changed the database parameters. Now before going to the production, you need to benchmark your database. Benchmarking means you are checking the performance. So whether your database is giving the good performance or not. So you need to put the load on your database. So how do you put? You may need require some tool for that. How you may write? You need to write your own script. So like I said, if you have 1,000 user, then you need to try with the 1,000 user at the time. You need to connect you need to put the 1,000 user load on your database. So that is what measure the performance of your database feature essential to the application, which is basically helps the DBA to preparing the system. Because then once you run that, so you will get the idea that what system resources is required for running the 1,000 user application, 1,000 concurrent user application, and what is the RAM size is required, and what is the CPU is required. So all this thing you will get a good idea about that. Then can available to database parameter changes. So if it is in parameters also required again, once you change, so you can also change the parameter based on the your that performance, the benchmarking report. You can identify the problematic areas, because here you will run your actual queries, or you will run some dummy queries. So sometimes it is used for comparing the different databases and help makes the file system choice for your data type. As I said, so you can put the load like a reading or the writing. So based on that, you can choose your file system. So to run the benchmarking, the PostgreSQL, there are many tools, but you can use the PG bench, which is the part of the PostgreSQL, which is installed with the PostgreSQL. You don't know to do it manually. You don't know to install it manually, which comes with the PostgreSQL, which is PG bench. Then benchmark SQL, this is also another tool, and the HummerDB. These are the tools are available, which are the open source tools. So you can use the tools for benchmarking the database. Here is a PG bench. So what is that? It is basically a program, and it runs the benchmark test on your PostgreSQL database. As I told you, no installation is required for this, and it is basically executable binary by default located inside the bin directory of your PostgreSQL. It is a TPC based, that means a transaction path control based, and it is designed like a basically a bank account and a teller module. Like there are 4 tables, and the same SQL will be run in a background again and again. But if you wanted to try with your own SQL, you can also try with that. It's basically PGBench basically used to connect the multiple database sessions and run the same SQL statement times. So like I said, if we have 1,000 user requirements before going to production, if you wanted to try whether that my database is capable to handle the 1,000 user connection, then you can run the PGBench with the 1,000 connection. So you can enable the logging parameter and you can check the logging. So you will get the idea that how much resources are used once that 100,000 connections are reached. So that is what that's the PGBench will help you. And calculate the average transaction rate. That is what transaction per second. It will calculate internally and generate the report. So basically the PGBench will run the select statement, update statement, and the insert statement in the background. You can see in the slide, so I have created one database called demo_db to initialize the PGBench. After that, the PGBench -i for initializing your PGBench, and it initializes the table. So it will create the 4 tables, which is PGBench account, PGBench branches, PGBench history, PGBench tellers. And you can also use the PGBench to run the custom script, not only that internal one. So you can also run your own script. You can say the 4 table is created, and the first table contains that 10K records, and another is a very small tables. PGBench accepts this many options, like -small c for client. So this is where you need to increase the number. So if you wanted to test the PGBench with the 1,000 user connection, you need to write -c 1,000. That means it will put the 1,000 user connection on your database. This means 1,000 concurrency connection on the database. By default, that is 1. And -c capital C. So establish a new connection for each transaction. So that is what I said. So if your application is using the new connection for the each transaction, then you may need to test with this -c. What happens once the transaction is complete? Again it disconnect, again it connect. This will basically uses the more CPU resources from your server. There's the two different. You can use the existing connection or you can use the new connection for new transaction. And the -f for file name, as I told you. So if you have some script, if you wanted to try with that script, so you can use that script -file and that file name. That script will be executed again and again. If you use 1,000 clients, then that script will be executed in the background 1,000 times. And -s, it only generate is the select statement. It will not run the insert, delete, or update. It only invoke select statement. And -t to number of transaction for each client. So by default 10. That means if you select 1,000, then PGBench will total 10,000 transaction. So you can set the -t, and if you wanted to set the 1 transaction per client, then you can set this one. Based on your requirement, you can set this. By default, it invokes the 10 transaction per client. Then now if you don't want to run it based on the client or a number of connection, if you wanted to run it for the some time, like for just half an hour, I wanted to run the 10 user connection for the 10 for the half an hour, then you can specify that in a time like capital T and the seconds. So that same process will be run again and again for that specified period. And you can also output that log by using the log prefix. These are the options are available in the PGBench. So basically these scripts are executed in the background. So which will update, select, again update, again insert. These statements are executed in the background again and again. So you can see here I run that -c 10 client and for the 60 second, that means 1 minute. On the demo DB, you can see here is the latency is 11 milliseconds for completing each one. Average is the 11 millisecond, and my TSP is 842. That means transaction per second. That is 842. The including the connection established and excluding the connection established. So you can see the difference is that there is no much difference. So but 842 is the TSP on. My system is like very small, which is the 1 CPU and the 1 GB RAM. See if you see there is the 1 CPU it is giving this much record. Then what about that if you have a dedicated system with the high RAM and high CPU, it will give you the good performance. But again, it depends on that query that you run on a database.